Hi guys, can you hear me? Okay, we'll start in 2 minutes. Can someone please post on the group that we are starting? Guys, can we start now? Someone please put it on the group that we are starting. Okay, guys, let us start. So we will start with a new data structure today. Let us do a quick revision of what we have covered so far. Okay. Can all of you see the screen? I hope the screen is visible. Someone quickly give me a confirmation on the chat. Screen is not visible. Lalit, my image. What do you mean? Guys, can you see the screen? Yes or no? I think my screen should be visible. Lalit, I don't know why you're not able to see, but I think the screen should be visible. Okay.
Yeah, it's
Cool.
visible.
Cool. So till now we have studied about some data structures. Okay. And I told you that when we started with our journey of data structures, that we are going to study the data structures in two. We classified that into two major parts. Okay. And we said that the first part was a linear data structure. Okay. And within linear data structure, what are the things that we have studied? We started our discussion with array. We studied about linked list, okay, stack, and queue. Okay, these four topics we have covered, and we have solved some problems, and we know about these data structures from the very basic. Now we are going to start with a new type of data structure, which is a non-linear data structure. And inside non-linear data structure, we are going to study about trees, graphs, and before the graph, I can put heap. Okay, these are the data structures that we are going to study, and these are very important, especially trees and graphs are very important topics. Okay, so these are the things we are going to study, and today we are going to start our discussion
And
specifically
total
with,
this much data structure we have, like tree, heap, and graphs.
sorry,
So only I have to study that much only, na? Tree, heap, and graph, no other.
नहीं और मतलब डेटा स्ट्रक्चर में इतना ही है, फिर एल्गोरिथम्स भी है सेपरेटली, बट हाँ मोटा मोटी इतना ही डेटा स्ट्रक्चर हम लोग को पढ़ना है. ठीक है, तो today's discussion is going to be about trees. So we'll do an introduction of trees, we'll understand the basic of trees, and after that today we will solve a few problems, and tomorrow also maybe 2 or 3 classes we'll spend on understanding trees and solving problems around trees. And within trees also we are going to focus on one major variety of trees which is called as a binary tree. Okay, so there are n-ary trees and we have binary trees. In fact, heap is also one variety of tree which we will see later. Okay, and binary tree, and then we also have here something called as a trie. Okay, but our major focus of learning is going to be on binary trees. Okay, so this is the agenda. This is what we are going to accomplish here. All of you are clear? Okay, so let me start our discussion with a recap of what we know about a linear data structure, and then we can understand about a non-linear data structure. So can someone tell me what was a linear data structure? Okay, data was arranged sequentially. Okay, or we can say that there was no hierarchy, or we can say that every element has one successor and one predecessor. We have discussed this, right, guys? Okay, and we traverse also in a sequence, has one successor and one predecessor. For example, we learned about arrays, right? So arrays, we were having elements like this, and we were storing elements like 10, 20, 30, 40. And from 10, we are going to 20, 20 to 30, 30 to 40. Or we can have a linked list like this. Okay, maybe 10, 20, 30, 40. So if you say what is the next element of 30, it is 40. What is the previous element of 30, it is 20. Okay, there is no hierarchy, there are no levels. Okay, similarly for a queue also. Okay, so this is array, this is the linked list. And similarly, we are having a queue also. So here also 10, 20, 30, 40. You know, here from you are entering the elements, here you are exiting the elements queue. Or we have a stack. Here also we have 10, 20, 30, 40. So there is an order or there is a series here. Okay. Now we are going to move towards a non-linear data structure. For example, in a linked list itself, if I, or the node concept, right? In linked list, when we study, we know about a node. And this node is having connection to another node. This node is having connection to another node. But I will start making it in such a way that this node can have one more connection, which is this. Okay. And this node can have another connection, which is this. And this node can have another connection, which is this. And this can have another connection, which is this. Okay. So this type of a structure becomes a tree, although this is not how we will visualize it. But you can see every node is connected to multiple other nodes. So it is a collection of nodes, okay, which simulates collection of connected nodes that is simulating a hierarchy. Now, this is not a bookish definition, okay, but this is for your understanding. And there can be other variety of this also. And this you can say that this is one to many relationship. This is one to many relationship. Do you understand what is one to many relationship? One node is connected to many other nodes. And where we might find this type of a structure? Okay, when we want to represent some relationships. Okay, or we can say relationships or hierarchy. And there are two varieties in this. One is one to many relationship, and we can also have many to many relationship. What would be many to many relationship? Or let us talk about, okay, many to many relationship we can discuss. For example, I have this node. This node is connected to this node, and this node is connected to this node, and this node is connected back to this node. Okay, and I am having one node. This is connected to this, and this is also connected to this. What is this? This we will say that this is a graph. This is a graph. We can also say that tree is a special type of graph. Tree is a special type of graph. But we will not talk about graphs right now. We'll talk a little bit more detail about trees. And before understanding about trees, the terminologies, I just want to give you a quick uh, idea of the application of tree. Okay. All of you are following so far, guys?
Yes, sir.
Okay. So, for example, I told you that when we want to simulate a hierarchy, for example, I can have that Imran is maybe the CEO of a company. Okay, let me make it to differentiate it from linked list. Let me make it like this. Suppose this is Imran. Okay, and Imran is having two reportees. There are two people who are reporting to Imran. Say, for example, Anil is reporting to Imran, and Ashish is reporting to Imran. Okay, and then Anil is having two more reportees, which is Tyler. Okay, and Abhimanyu. And Ashish is having two reportees. One is Saif, and the other is Imtiaz. Okay, so this is what a tree looks like. Now here I have drawn it like this, but maybe Anil can have three people reporting to him, and the third person can be maybe Mustafa. Okay, and Saif can further have one person reporting to him, which can be Lalit. So this is a data structure called tree. Now, why is it called a tree? Because if you look at a tree looks like this. Right? A tree looks like this. I may not be a very good with sketching, but this is what a tree looks like, correct? And this part of the tree, we say that this is a root, okay? And there are some leaves here, okay? So this part of the tree, these are called as branch, okay? And these are called as leaves. Why they are called as leaves? Or what is the definition of a leaf? Leaf is the last extension of a tree, the last part, the tip of a tree. Is that right? So if you invert this structure that I've made, इसको अगर उल्टा कर दें अगर, तो ये भी एक ट्री जैसा लगेगा. This also will look like a tree. See this, इसको उल्टा कर दिया मैंने. See, this also looks like a tree. Does this look like a tree, guys? So
Yeah.
this is sorry, this is a general tree. Now there are some terms that we use in a tree. The first term is that the starting. Okay, these are all nodes. We will say these are all nodes. This Imran is a node. Anil is a node. Anil is the data inside that node, of course. Okay. Ashish is the data inside this node. So maybe this is node number 1, this is node number 2, this is node number 3, this is node number 4. And these numbers are not for the order. Okay. Just for labeling, I'm putting it. 4, 5, 6, 7, 8, and 9. Okay. All of you are clear till here, guys? So some terminologies, which is that this node, I will say this is the root node, or we'll just say this is the root of the tree. Very obviously, why? Because this is where everything is starting. Right? And we'll say 2 and 3, these are children nodes. Or we'll say child nodes. So this is the root node, and these are the child nodes. Okay. And similarly, Anil will say this is the parent node. And again, we will say that 4, 5, and 6, Mustafa, Tyler, and Abhimanyu, these nodes are children nodes. Children nodes. Child nodes of node 2. Abhimanyu saying decision tree in ML. Yes, decision tree in ML is a special type of tree. Correct. the idea of decision tree is the fundamental idea is very similar. So what did we learn? So we learned about some terms, terminologies. Terminologies around tree. I'll not give you any definition, okay? Just understand the basic, because when you're solving problems, the definitions are not very important. But we understood what is a root. First of all, what is a node? Root node, okay? Child node, parent nodes, okay? What else is there? The nodes which are not having any children. For example, this node. This is not having any children. So this is called as a leaf node or the end of the tree. Okay, very similar to the example that I gave you here, leaf node, which has no children. Okay, when there are no children, we can simply say that this is null and this is also null, something like that. But that is more in a binary tree. Here, there's no need to make it like that. Okay, so we know about leaf nodes. All of you are clear, guys, till here? Now, we will also say that Anil and Ashish. Now, Imran is also a root node. Imran is also a parent node for Anil and Ashish node, right? So we can say that Anil and Ashish are sibling nodes. Anil and Ashish are sibling nodes. Okay. Similarly, we can also say that for Abhimanyu node, for this node, which is the parent node or which are the siblings for Abhimanyu node? Can someone tell me? For Abhimanyu, Tyler and Mustafa are sibling nodes, right? And what about Abhimanyu and Saif? Can we say Abhimanyu and Saif are cousin nodes? Because their parents are siblings, because Anil and Ashish are sibling nodes, right? So these terms are very, very intuitive. These are very commonsensical terms. Similarly, Imran is a grandparent node for Abhimanyu. It is a great grandparent node for Lalit. Similarly, we can say that Ashish is the uncle node for Abhimanyu because sibling of parent. Sibling of parent is a uncle, right? So these relationships you should be able to understand. Although mostly we will use parent node, child node, sibling node, cousin node max, not so much. But we can say also say grandparent node, uncle node, sister node, all those things. Okay, this basic thing about nodes is clear, guys. Now, this type of tree that I've made, this type of a tree is called as an n-ary tree. This type of a tree is called as a n-ary tree. Why n-ary tree? N-ary tree, n here define means any number of children that can be there. So for Anil there are 3, for Ashish there can be 4, for Lalit there can be 5. Okay, so this is like a general tree. So we don't discuss much of general tree. This is just for introduction. But mostly we are going to talk about not n-ary tree, but binary tree. So we'll talk about more. Say that when we talk about trees, that there are n-ary trees and binary trees. So we are going to focus more on binary trees. So what will be the definition of a binary tree? Binary tree means can have at most 2 children. Okay, and these children are called as left and right. Sev is asking what can be a real use case of tree. Use case of tree I discussed here. Okay, when we want to simulate a hierarchy, for example, a organization ka structure, who is reporting to whom, a family tree. You must have seen in many movies they have a family tree, uncle, aunt, who is the child of whom, who got married to whom. You can make a tree to simulate a hierarchy or a relationship. For example, directory structure in your computer system. You create a folder called user folder. Okay, inside the user folder you have uh, user one user folder, and inside the user folder you can have three different user, maybe user one, and then you can have user two, then you can have user three. Okay, now user one is having some documents folder, some downloads folder, some pictures folder. Okay, within pictures you have uh, trip photos, school photos. Okay, you can have your picnic photos. User 3 can have work related folder. Can you see this is becoming a tree? Saif Akhtar. Okay, this is also used to also used for inserting, searching, and deleting data efficiently. So we'll learn later about binary search trees. We have learned about binary search and we have learned about arrays. Okay, so we'll also learn about binary search trees or relationship. For example, um, storage hierarchy or family tree or organization tree, something like that. Is it clear, guys? So when we talk about binary trees, we say that it can have at most 2 children. So going forward, we are going to talk more about terminologies around a tree, but we will focus more on a binary tree and we'll try to understand it.
So why do we focus on binary tree? Why don't we give the importance to other trees?
It's not that we don't give importance to other trees, but in our study, what we want to study and for what purpose we are studying, in that mostly binary trees are focused. The algorithms that we are going to learn. It's not that other trees are not important.
Okay.
Data structures are only as important as our requirement, what we need, right? So when you are working and you need an array tree, you will make an array tree. You want a balanced tree, you make a balanced tree. You want to make a trie tree, you make a trie tree. Okay, we want to make a heap, we make a heap. But for our study, for what purpose we are studying, most of the focus is around binary tree. It does not mean that the other tree is not important.
Okay.
And even if they are important, when we are understanding it, things become easier to understand when we are learning about a binary tree. So we were talking about the trees. I will make some general trees now. So I will take like this 15, 20, maybe 30, 16, 18, 40, and 60. So you see, this is a binary tree. Some other examples of a binary tree: 15, 16, 17, 18 and 19. So this is also a binary tree. This is also a binary tree. I can simply make 10, 20, 30, 40 and 50. This is also a binary tree. Here there are no nodes. Maybe here I can just add. Here I'm not adding anything. So there are no nodes here. As a very special case, I can also make a binary tree like this, which I can say 5, 6, 7, and 8. So is this also a binary tree? But does this look like some other data structure that we have learned?
Yeah, linear data structure.
कौन सा linear data structure?
Linked list.
Linked list.
This also looks like a linked list. But it is also technically a tree. Binary tree. So later when we learn about binary tree and binary search trees, we'll see that this is one special case of a tree. जिसको अगर हम ठीक से if we don't balance it properly, then if it becomes a linked list, then it is not giving us the benefit for the reason we are using a binary tree. But technically this is also binary tree. If I simply make one node like this, 20, this is also binary tree, because what is the definition I said? That at most 2 children. So it can have 0, 1 or 2. 0, 1 or 2 children. Okay, so if I make this 20, this is also binary tree. If I make 20 and 115, this is also one binary tree. And there can be empty tree where there is no node. Okay, so that is one, like linked list mein hum log we used to have one none. So that we used to say it is a empty linked list. So here we'll say that if we take example of this 15. Okay, so if you want to imagine this tree, I want to imagine this tree. Let me make. These are all trees. So this is the tree that I'm talking about. So here we can also represent it like this. We can say that I'm having one node here. Okay, and this node contains the data 15. Okay, and this contains a reference to another node. And this contains the data 20. And this contains a reference to another node where the data is 16. And this contains reference to another node which contains the data 18. So this is similar to the linked list that we studied, except that there is hierarchy. It is not linear in nature. Similarly, here we can come and we can say that this is a reference to a node where we have data 30. And there is one left node, and left node is pointing to another node where data is 40. And this is pointing to another node where the data is 60. So this is how we are going to represent, or another representation of tree as nodes. So what exactly is this node? इसमें क्या स्टोर कर रहे हैं? Okay. यहाँ पे हमारे पास डेटा है. We are having data. And here we have the right child. And here we have the left child. So if you remember, in a linked list we were saying next pointer, previous pointer. Okay, this is the node. Are you guys following? So far so good. So let me talk about few more terms here, which is height of a tree.
Sir, but here also we're using like in structure of a linked list, right? Even though it's a non-linear, as a node. Node has left and right bidirectional.
Yes, but it is not called a linked list. Linked list जब linear होता है तो उसको linked list बोलते हैं. This is the graph.
ये
Sorry,
क्या
this is a tree.
रिप्रेजेंटेशन ऑफ ट्री, इसका थोड़ा सा ये कैसे अपने आप आ गया ये डेटा?
अपने आप आ गया डेटा मतलब?
ये 15 पहले से नोड था, तो ये ट्री मेरे पास 20 30 है,
हम्म,
तो ये मतलब उसमें कुछ रूल रहेगा ना कि ट्री बनाने के
नहीं,
लिए?
रिप्रेजेंटेशन बता रहे हैं, अभी तक नहीं बताया. इट्स जस्ट रिप्रेजेंटेशन ऑफ द.
जो ये बनाया मैंने, इसको ही अगर मैं आपको बोलूँ कंप्यूटर मेमोरी में आप ऑर्गेनाइज करो, इसको कैसे, ये जो 15 यहाँ पे मैंने गोला बना दिया, ये गोला क्या है, ये क्या स्टोर कर रहा है?
ये नोड नोड स्टोर कर
ये
रहा है।
नोड है, तो ये नोड क्या स्टोर कर रहा है? इसके पास क्या इंफॉर्मेशन है?
डेटा है.
इसके पास तीन चीजें हैं. एक तो डेटा है.
एड्रेस,
The first thing that it has is its data. That what is the data it is storing? It is storing 15, and it is storing information about its left child.
लेफ्ट चाइल्ड मतलब
लेफ्ट
ओके,
चाइल्ड का
राइट
मतलब ये
साइड ना?
20. ये 20 के नोड को पॉइंट कर रहा है. यहाँ पे एक 20 नोड है, यहाँ पे एक 30 नोड है. It is not storing the node, it is storing the address. But I hope you got. MT is asking what happened to multiple left and right childs. What happened if the multiple left and right child means there can be only one left and one right child. That's why I said here that you can have at most two children. There can be at most two children. There can be no children, which is here. There is no children. Or no children means leaf node. For example, 16 has no children, 18 has no children, 40 has no children, 60 has no children. Okay? 15 has two children. 20 has two children, but it is possible that a node might not might have just one child. For example, 19 here can have only one child maybe.
Sir, but this is the scenario if there's a one child or one left and right. What if a parent has multiple childs? Because वो नी-
Parent cannot have multiple childs, only two. That's why it is binary tree. Bi means what? Two.
लेफ्ट एंड राइट ओनली ओनली टू चाइल्ड.
Left and right, दो बच्चा होगा. Left and right.
उसके फर्दर होगा तो चाइल्ड टू चाइल्ड होगा उसमें.
There won't be anything further. If it is further, then it is not a binary tree. It is not 0 or 1. 0, 1 or 2. Lalit, it is not n array, it is n array. N array matlab binary, trinary, binary, trinary. So similarly, it is n any n nodes. So n array. It is not an array. Okay. Is it clear, guys, till here?
सर ये अगर ये ट्राइनरी होगा तो फिर कैसे इम्प्लीमेंट होगा?
3 नोड्स बना देंगे हम लोग. वो नहीं डिस्कस करेंगे, लेकिन 3 नोड्स हो जाएगा वहां पे. तो हम एक जनरल स्ट्रक्चर बना देंगे कि एक नोड होगा, उसका कितना भी चाइल्ड हो सकता है. एक जब नोड बनाएंगे, सपोज 15 ऐसे नोड बनाए, तो उसका कितना भी चाइल्ड हो सकता है.
तो इसमें हम लोगों को जो पॉइंटर रखना होगा बहुत मतलब कितना भी रख सकते हैं, पॉइंट आउट करेगा.
आप एक डिक्शनरी बना लो. आप एक डिक्शनरी बना सकते हैं. ग्राफ्स में देखेंगे हम लोग. ग्राफ्स एक जनरल ग्राफ जो है, वो ट्री जो हम लोग पढ़े वो एक जनरल स्पेशल केस ऑफ ग्राफ है. जब हम लोग ग्राफ पढ़ेंगे किसी भी टाइप का कनेक्शन, अब जैसे यहाँ पे वन डायरेक्शनल है, 15 से 20 है, 20 से 15 नहीं है। पूछोगे अगर उल्टा भी हो तो क्या होगा? तो ग्राफ जब हम लोग पढ़ेंगे, व्हेन वी स्टडी अबाउट ग्राफ, देयर वी विल सी जनरल रिप्रेजेंटेशन ऑफ दिस हायरार्की, but right now we are studying a very specific use case of that. But you can, if you want, you can store it as a dictionary. You have 15, you say कि इसका एक child 20 भी है, एक child 30 भी है, एक child 40 भी है, and 20 का there are multiple childs, you store it as a dictionary that 15 के कौन कौन से childs है, okay, and then 15 के child है 20, 30, 40, and then 20 के कौन कौन से child है, 30 के कौन कौन से child है. So this is called as adjacency matrix. We will study about this later. Okay, but for now we are dealing with only 2 children. If you have 3, 4, 5, 10 children, it's not that it cannot be implemented. Is everyone with me so far? So I was talking about some more terminologies around tree. So one is height of the tree. Okay. Then we have depth of the tree. Before height and depth, I want to talk about edges also. These 3 things let us talk about. So first of all, when I told you a tree, suppose this is a tree. Okay, this I said this is a tree. So this is a node and it is connected to 2 other nodes using what? How it is connected? It is connected to this node and this node. So these are called as edges. So if you have few things, few ideas that we can discuss here, is that if you have one node, then how many edges are there? If you have only one node, then how many edges are there?
2 edges.
If node is 1, then how many edges are there? Right now there are 0 edges. Correct? And we can have one node here 16 and one node here 17. So nodes have become 3. Or if you have just 2 nodes, then how many edges you have? We have 1 edge. But if I create 3 nodes, then how many edges we have? 2 edges. If I create more nodes, 18, 19, 20, 30. How many nodes are there? 1, 2, 3, 4, 5, 6, 7. How many edges are there? 6. Okay. So if you have n nodes, we have n minus 1 edges. Max. It can be no n minus 1 edges only. Is this idea clear? Now these are not something that is to be told, because obviously you will be able to derive these things when the requirement is there. But I'm just trying to familiarize you with the different aspects of trees. Okay. Now if I talk about, okay, n nodes have n minus 1 edges. Now you have to think of it this way, that why n minus 1 edge? Because every node, okay, number of nodes will be equal to number of edges minus the root node, because root node does not have an incoming edge. That's why that minus 1. Okay. Or whichever way you want to see it, that is completely okay. I want to talk about height and depth. So I will take this tree. And this is important.
Sorry, just I have one quick question.
Please.
Yeah, so in these nodes, right? So you are creating like 15, 20, then 16, 18. What happened
Mhm.
if 16 to 18 we have another edge? Is it possible if in this kind of trees?
No.
Yeah.
No. If you do this,
Right.
then it becomes a graph.
Okay.
Okay. If this happens, because I told you that a tree has 1-to-1 relationship. Sorry, 1-to-many relationship.
Yeah. Thank you.
So one node can be connected to any number of nodes. Okay. But every node should have one incoming. Or you can say that every node can have multiple outgoing, but it cannot have multiple incoming. If you have multiple incoming, then it becomes a graph. So here, if you do like this, then 3 is not 1-to-1. It is many to 1 because this is 1 and 2. It has become like this. Okay. So this way it is a tree. This way it is not a tree.
I have one question here. In the 16 or 18, can
Graph will have, one second, graph will have many to many relationship. Yes, please tell me.
here suppose 16 or 18 can create the multiple nodes also, like 2, 3, more than 3, 4, right?
16 can create multiple nodes.
Yes, like 3.
Like this.
Yes, yes.
Yeah, it can create.
3, 4s, any, right? There is no restriction to only create a 2 or 3, right?
What do you mean? Sorry.
Suppose 16, I want to create 4 nodes here, like 20, 13, 14, and 16. That will be possible.
20, 30 ऐसे करके.
Yes, correct.
यही तो बता रहे हैं ना कि 2 ही child हो सकता है ना.
Most 2 child.
We can have only at most 2 children.
Yeah, got it.
If you have more than 2 children, then it is a tree, but it is not a binary tree.
Binary. Bi means two only maximum.
Bi means 2. ठीक है. So here what? 15 is a parent. 15 is having how many children? 20 and 30. 20 is a parent, how many children? 16 and 18. 16 is a parent, how many children? 2, 20 and 30. 2 children होगा, दोनों का नाम, एक का नाम होगा लेफ्ट, एक का नाम होगा राइट. Okay. Now I want to talk about depth of the tree. Or before that, I want to talk level. So we will say that this, and this is important. Okay. This is level 0. This is level 1. And this is level 2. And this is level 3. Okay. Level 0, level 1, level 2, level 3. So on level 0, we will also say this is depth. This thing, we will also say this is depth. Are you guys following? Anyone having any question till here? So if you have level 0, okay, if I'm asking you how many nodes, I will say level. I will say nodes. So at level 0, how many nodes are there? Maximum, how many nodes can be there? At level 0. At level 0, how many nodes can be there? There can be one node. Root node. This is the root node. Okay. At level 1, how many nodes can be there? Maximum. There can be only 2 nodes. Are you guys following? Why? Because it will have only one child. Now at level 2, how many children can be there? These 2 can have total how many children? 4. Okay. At level 3, total how many can be there? This is max nodes. It is not necessary that it will have 4, but maximum it can be 4. So this will be how much? 8. So this is what? This is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. So at nth node, nth level or h level, n we will denote for, okay, at level h, how many nodes will be there? 2 to the power of h. Is it clear? These things will come in handy later. N nodes have n minus 1 edges. H levels have 2 to the power of h nodes. And how many h level will how many have edges? You can use these two relationships to find out. So what will be total number of nodes? Total nodes at level h will be 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of h. Again, there is no need to memorize all of these things. I'm just showing you that these are some of the things that you have to keep in mind. So what can I say about depth of a node? I gave you level, but I wanted to talk about depth. The depth of a node. What is the depth of this node? Say, I am asking you, what is the depth of this 16 node? It is 2. How did we arrive at 2? We can say that number of edges from the root. Okay, number of edges from the root. Number of edges from root. Some places you will see people saying number of nodes, but number of nodes will be ambiguous because you will count 15, 20, 16. So sometimes you can get confused and say 3, but no. It will be number of edges that is needed to reach from the root. Okay. And similarly, we also have height of a node. So what will be the height of a node? Suppose I'm asking you, what is the height of 20? इस node का height क्या है? So depth you are taking from top, okay, and height you are taking from bottom. Okay, so this is the height. So Ganesh is saying 2. Why? Ashish is also saying 2. Why? How did you arrive at 2? Last on Edges from the bottom. From bottom how? Which bottom? This bottom or this bottom? Why not one? Why can't I say this is one? Edges from the bottom. Which bottom? So what you are getting, what you are saying is correct. Intuitively, you are coming to the right answer. But we'll say the longest path. So here, which are the leaf nodes? Okay. So this is a leaf node. This is also a leaf node. This is also a leaf node. This is also a leaf node, and this is also a leaf node. Okay. These are leaf. Okay. So here we will say that the height is number of edges in the longest path from node to a leaf. So we'll take the longest path from node to the leaf. Leaf means the edge. Is it clear, guys? Still here, all of you?
So, but in this case, what will be the depth of the node and height of the node? Because it's like longest part is 15, 20.
Which node?
Now, for example, here 15, 20, 16 and 20 means it's like the longest height of the node.
You're trying to find the height of which node?
The on left side one, 15, 20, because it's the height is the 15, 20, 16, 20 is the longest.
I'm asking you a question. Which node you're trying to find the height? Are you trying to find
15,
the height of this 15?
Yes.
15. Okay. So which is the leaf node for which it is having the highest path? So this is one leaf node.
Yes.
So it is having 1 and 2.
Okay.
Okay. This is also a leaf node.
Yes.
Here also it is having 1 and 2.
Yes.
This is also leaf node. Here it is having 1 and 2. But this is also leaf node. But here it is having 1, 2 and 3.
Okay.
What is the height of the tree?
3.
Level 0, level 1, level 2, level 3.
And sir, regarding the depth of the node, a number of edges from the root.
Height of tree is 3. Tell me, sir.
So regarding depth of the node, number of edges from the root.
From the root.
So is there any maximum, minimum, or which is?
There is only one unique path.
So which is the unique path? I mean, there are edges in almost like all the directions here.
You take any. Tell me. Pick one node.
15. Say imagine 15 as a node.
Which one? 15 kahan hai? This is 15.
Root node.
So root node is at root, so there is no depth. Depth is 0. It is on top.
Okay. Fine.
Depth is it is at level 0, so depth is 0.
Okay.
See,
I got it.
Understand. Few more things. Okay. If you take any tree, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. If I ask you to find the depth of any node, for example, this node, what did I say? Depth. Number of edges from root to that node. Okay. Or number of edges. I can make it a little bit better. Number of edges in path from. So you want to find this. So what is the path from the root? This is the path.
Yeah.
There is a unique path. Is there any other way to reach 80 from 10?
No.
So there is only one unique path. In that path, how many edges are there? Edge number 1, edge number 2. So depth is 2.
Yeah, fine, sir.
I can also say that this is my level 0. This is my level 1. This is my level 2. So by that virtue also, you can say that this is 2, or you can count the number of path also, number of edges also, whichever way. There should be no ambiguity in this. But when I say height, okay, I say number of edges from node to a leaf. So now you can say there can be multiple different paths, number of edges in the path, number of edges in path from node to leaf node. Okay, so if I say what is the height of 20, what is the height of 20, suppose, and there is one more node here, maybe here there is a node called 10. Okay, so if I say what is number of edges in the path from node to leaf, so this is also one path, correct? No, and this is also another path. So you will say which path? So that's why I gave here longest path, number of edges in longest path. From node to that leaf. Is everyone clear? Now there is one thing that I want you to understand in a tree or binary tree or anything. It's a topic that we have not discussed so far, but I want you to have a feel of it, okay? Which is called as the recursive nature of trees. Do you guys understand what is recursion?
Repeatedly following the same loop. Recursive.
Repeatedly following the same rule. You tell me if
Same loop means calling the same loop again and again.
calling the same loop again and again. Is that the right phrasing? Function calling itself, fine. I will not give you the definition of recursion. Okay, Imtiaz is saying no termination. But I'm just trying to visualize and give you a feel of what I'm trying to say. Okay, recursion we'll study separately. But you see that if I create a tree here, suppose I'm creating a tree 10, 20, 30, 40, 50, 60, and 70. Suppose this is a tree that I've created. So if I take this part out, if I just talk about this part, is this also a tree?
Yeah, it's a subtree.
Subtree. And if I talk about this one, is this also a tree?
Yeah.
Okay, so can I say, can I represent 10 as having left and right, and further here is one tree and here is one tree. You can say tree 1 and tree 2. Okay, so a tree is containing a tree. Okay, and that tree is further containing a tree. Can I say that this is also one tree? And this is also one tree. So this further is a tree, and this further is a tree. So very often, right now we don't want to discuss much about the recursive nature. But going forward, we are going to utilize this thing, that if we know to perform some operation in a tree, okay, we can use that same function to go down and apply that same thing on the subtree. We perform some operation on 10, okay, and then we perform it on tree 1 and tree 2, and that same function further will be used within tree 1, within tree 2, like that. It is difficult to imagine right now, but when we start writing, solving some problems, you will see that this recursive nature or self containing self similar structures, okay, will be very, very useful going forward. All of you are clear till here? I want to start another concept. So this is the basic of trees. Now let us try to understand some algorithms on trees. Okay. And the most important thing that we are going to learn about trees is tree traversals. Okay. Guys, we'll take a break for some time and then we'll start. It's 5:10.
अच्छा, इसमें मेरे को क्वेश्चन है, जैसे कि डेटा
एक
जो
मिनट रुक
स्टोर
जाओ,
होता है, जैसे
एक
हमारे
मिनट
पास
एक मिनट एक मिनट एक मिनट. Okay, it is 5:10. Guys, we'll take 15 minutes and we'll be back by 5:25. Okay. हाँ बोलिए.
अभी डेटा जैसे मेमोरी में स्टोर हो रहा है, तो उसके लिए
हम्म
हम डेटा स्ट्रक्चर वो कर रहे हैं, तो उसके लिए
हम्म
अभी जैसे लिस्ट हो गया और
हम्म
आपका लिंक लिस्ट, ये सब मतलब लिनियरली स्टोर होता है।
हम्म.
लेकिन जब ये ट्री है तो मतलब कि मेरे को समझ में कैसे आएगा कि ये मतलब कि ग्राफिकल ये इस तरह से स्टोर हो रहा है, मतलब थोड़ा सा एक बार पिक्टोरियल टाइप का थोड़ा बोल सकते हो कि मतलब कहाँ पे इसका मतलब कि वो पार्ट होता होगा। जैसे कोड रन कर रहे हैं तो पूरा उसका जो स्टोरेज है मेमोरी में होता है, इसीलिए हम डेटा स्ट्रक्चर की मेमोरी को मिनिमाइज करने के लिए, ऑप्टिमाइज करने के लिए हम ये डाटा स्ट्रक्चर यूज कर मतलब समझ रहे हैं, ताकि थोड़ा ऑप्टिमाइज कोड लिख पाएँ।
हम्म.
तो लेकिन इसका मतलब कि मतलब कहाँ पे ये मतलब कि हो रहा है मेमोरी में, मतलब किस तरह से ये उस तरह से ट्री स्ट्रक्चर बना रहा होगा।
ये बताया ना यहाँ पे, ये देखो.
जैसे ये तो समझ में आया कि जैसे हमने कोई प्रोग्राम लिखा तो उसमें हम डेटा वेरिएबल स्टोर किए, वो सारा मतलब या तो लिनियर होगा, मतलब कि अरे लिंक लिस्ट टाइप का होगा या स्टैक होगा, वो एक स्ट्रक्चर है उसमें मेमोरी लोकेट करता है। और ये ट्री वाला का थोड़ा सा क्या मतलब उसमें
अब
इसमें
ऐसा, आप ऐसा तो नहीं इमेजिन कर रहे कि ये कंप्यूटर का मेमोरी है,
हाँ हाँ कुछ इस तरह से ही, हाँ।
बड़ा सा मेमोरी है, ऐसे करके ढेर सारा राइट इसमें सेक्टर्स है, और यहाँ पे हम ऐसे करके एक ट्री बना देंगे, ऐसे होता, ऐसे आप सोच रहे हो क्या?
नहीं नहीं ऐसा नहीं, मतलब कि
हाँ,
मेमोरी का थोड़ा सा मतलब थोड़ा एक फैक्टोरियल बता सकते हो क्या उसमें, मतलब
पिक्टोरियल ही
क्या
बता रहे तब से,
मतलब
देखिए.
क्या हो रहा होगा उसमें ग्राफ के अकॉर्डिंग
बता
मतलब।
रहे, देखिए बता रहे. अब क्या होगा जब हम नोड बना रहे हैं, हम इसको जब रिप्रेजेंट कर रहे हैं, तो ऐसे रिप्रेजेंट कर रहे हैं 15, 16 और 18, ऐसे कर दिए रिप्रेजेंट पेन और
नहीं
पेंसिल पे.
नोड हम मतलब बना क्यों रहे हैं, मतलब उसका कुछ रिक्वायरमेंट है क्या, मतलब कुछ ऑप्टिमाइज हो रहा है क्या उसके वजह से।
सुनिए सुनिए, जब इसको पेन और पेपर पे हम लोग समझ रहे हैं, तो हम लोग इसको इस तरह से ड्रॉ कर रहे हैं, एरो बना बना के, पॉइंटर
हाँ
बना
ठीक
बना
है।
के. ठीक है. लेकिन जब ये कंप्यूटर मेमोरी में स्टोर होगा, जैसे जब एरे पढ़ाते थे, तो
हाँ।
मैं ऐसे बना देता था.
हम्म।
ठीक है. तो आपको लग रहा था कि अच्छा ये ऐसे ये है और यहाँ पे ऐसे दो ऐसे स्प्लिट हो रहा है, तो मेमोरी में कैसे ये स्टोर होता होगा। एक्चुअली अगर आप देखोगे कि डायनामिक एरे भी जब हम लोग बनाते हैं, एक्चुअल जो डेटा है, सपोज ऐसे 10 है, 20 है, 30 है, 40 है, 50 है, ये ऐसे थोड़ी ना एक जगह पे स्टोर रहता है डायनामिक एरे में।
नहीं नहीं, वैसे नहीं रहता। हाँ, राइट।
ये 10 कहीं और है, 20 कहीं और है, 30, 40, 50 कहीं और है, सब छितराया हुआ इधर उधर है।
हम्म
ठीक है, उसका जो एड्रेस है उसको हमने यहाँ पे एक एरे में स्टोर कर दिया।
हम्म
ठीक है, इसको ऐसे स्टोर कर दिया। वैसे ये जो 15 16 है, इसका मेमोरी एड्रेस इस तरीके से स्टोर्ड है कि एक हमने यहाँ पे हम एक स्ट्रक्चर बनाए 15, एक
हम्म
मेमोरी लोकेशन लिया, ये हमारा एक मेमोरी लोकेशन है।
हम्म
इस मेमोरी लोकेशन में हम तीन चीज स्टोर किए,
हम्म
तीन चीज स्टोर किए हुए, एक तो डेटा स्टोर किए हुए हैं,
हम्म
और एक और मेमोरी एड्रेस यहाँ पे स्टोर किए हुए हैं, और एक और मेमोरी एड्रेस यहाँ पे स्टोर किए हुए हैं। ये जिसका भी
हम्म
मेमोरी एड्रेस है,
हम्म
जैसे पहले एग्जांपल दिया हमने कि एक कोई इम्तियाज है, सपोज आपका कंपनी है, उसमें कंपनी में आपको एम्प्लॉय का ऑर्गेनाइजेशन हायरार्की आपको स्टोर करना है।
हम्म
ठीक है, तो इम्तियाज एक मैनेजर है, इम्तियाज के अंदर अरुण एक आदमी है और सुनील एक
हम्म
आदमी है।
हम्म
ठीक है, तो इसको आप कैसे स्टोर कर, क्या पॉसिबिलिटी है इसको अलग अलग तरीके से स्टोर करने का। एक तो आप बोलोगे कि हम इसको एरे में स्टोर कर लें, यहाँ पे हम इम्तियाज डाल दिए, यहाँ पे अरुण डाल दिए, यहाँ पे सुनील डाल दिए, आप ऐसे स्टोर कर लिया। तो कोई यहाँ पे रिलेशनशिप तो समझ में नहीं आया कुछ,
नहीं।
कि ये अरुण और सुनील इम्तियाज का जूनियर है, ये तो समझ में नहीं आया इसमें।
नहीं है।
कर सकते हैं आगे चल के, जब बाइनरी सर्च ट्री पढ़ेंगे तो हम लोग ट्री का एरे इंप्लीमेंटेशन भी होता है वो भी देखेंगे, लेकिन अभी जितना हम लोग डिस्कस किए उसमें इसमें तो नहीं समझ में आ रहा है। तो हम लोग क्या कर रहे हैं, हम लोग एक मेमोरी एड्रेस ले रहे हैं, उस मेमोरी एड्रेस में हम लोग इम्तियाज को स्टोर कर रहे हैं।
हम्म
ठीक है, और उसके बगल में एक मेमोरी एड्रेस में हम लोग अरुण को स्टोर कर रहे हैं, और
हम्म
एक यहाँ पे मेमोरी एड्रेस में हम लोग सुनील को स्टोर कर रहे हैं।
हम्म
तो जब हम इम्तियाज के पास जाएंगे तो इम्तियाज के मेमोरी लोकेशन के बगल में हमको इम्तियाज के जूनियर का भी मेमोरी लोकेशन मिल जाएगा,
हम्म
और इसके इस साइड में हमको अरुण का भी मेमोरी लोकेशन मिल जाएगा। तो है
हम्म
तो ये एक मेमोरी एड्रेस ही, लेकिन ये मेमोरी एड्रेसेस जिस तरीके से ऑर्गेनाइज्ड है वो एक डेटा स्ट्रक्चर है।
हम्म
इसको हम बोलते कि नहीं ऐसे मत स्टोर करो, ऐसे ना स्टोर करके आप ऐसे स्टोर कर लो कि हम एक ऐसा नोड बनाएं जिसमें हम इम्तियाज को डाल दें, और इम्तियाज का नेक्स्ट पॉइंटर में हम एक नोड डाल दें, और यहाँ पे हम सुनील को डाल दें, और इसका प्रीवियस में एक नोड को हम डाल दें, सॉरी ऐसे डाल दें, ऐसे एरे एक और नोड बना दें, यहाँ पे हम सुनील को डाल दें। तो ये क्या हो गया, सुनील से इम्तियाज, इम्तियाज से अरुण मे बी यहाँ पे,
हम्म
इसको भी हम स्टोर कर दिए, ये भी मेमोरी एड्रेस ही है, ये भी एक मेमोरी एड्रेस है, ये भी एक मेमोरी एड्रेस है, ये भी मेमोरी एड्रेस है, लेकिन जिस तरीके से ये ऑर्गेनाइज्ड है ये लीनियर हो गया, ऐसे हो गया।
हम्म
इसमें भी हमको ये नहीं समझ में आ रहा है कि इम्तियाज का जूनियर कौन सुनील है, अरुण है, कौन है। इससे हमको ये समझ में आ रहा है कि सुनील के बाद इम्तियाज आया, इम्तियाज के बाद अरुण आया। तो अगर आपको ये स्टोर करना है कि कौन किसके बाद ज्वाइन किया कंपनी में,
हम्म
तो आप लिंक लिस्ट यूज कर लेना।
हम्म
लेकिन अगर हमको ये जानना है कि हायरार्की क्या है, तो हम इस तरीके से ऑर्गेनाइज कर लेंगे। तो है तो मेमोरी एड्रेस ही, चीज एक ही स्टोर हो रहा है, लेकिन वो मेमोरी किस चीज को पॉइंट कर रहा है और वो किस तरीके से सजाया हुआ है, वो डेटा स्ट्रक्चर है। अब मुझे आपका क्वेश्चन समझ में आया नहीं कि आप एग्जैक्टली क्या पूछ रहे हो, लेकिन जो मैं बता रहा हूँ ये यही आप पूछ रहे हो या आप कुछ और पूछ रहे हो।
नहीं, मैं वो थोड़ा मैं समझना चाह रहा हूँ कि जैसे हम ये कोड लिखेंगे, जैसे ये ट्री का स्ट्रक्चर का
हम्म।
मेमोरी में मतलब कैसा उसका स्टोर होता होगा। जैसे कि अरे में तो हमको एक मैप में दिमाग में समझ में आया कि वो लिनियरली स्टोर हो रहा है, मतलब उसका एड्रेस ही स्टोर हो रहा है। ग्राफ मतलब क्यों है, हाँ कॉन्सेप्ट तो थोड़ा समझ में आया।
यही स्टोर हो रहा है। सपोज आपके पास तीन आदमी है, तो आपने एक मेमोरी एड्रेस, आपको मैं बताता हूँ, ये मेमोरी एड्रेस यहाँ पे आपने इम्तियाज स्टोर कर लिया।
हाँ।
ठीक है, एक और मेमोरी एड्रेस में आपने सुनील स्टोर कर लिया, और एक और
हम्म
मेमोरी एड्रेस है इसमें आपको अरुण स्टोर कर लिया। ये तीन मेमोरी एड्रेस है। ये मेमोरी
हम्म
एड्रेस 100 है, ये 200 है, ये 300 है। ये स्ट्रिंग है, ये एक स्ट्रिंग है।
हम्म
तीन स्ट्रिंग आप स्टोर कर लेते हो, ये ठीक है, तीन स्ट्रिंग आपने स्टोर कर लिया। ठीक है, अब इसको ट्री कैसे बनाएंगे, मैं ट्री ऐसे बना दूंगा। यहाँ पे मैंने 100 लिया, यहाँ पे मैंने
हम्म
200 ले लिया, और यहाँ पे मैंने 300 ले लिया, बन गया ट्री।
हम्म
ऐसे नहीं लिया, सॉरी गलती। यहाँ पे मैंने 100 का लोकेशन डाल दिया और यहाँ पे एक दूसरा नोड डाल दिया। ये नोड है मे बी 500 और ये नोड है 600। ओके, और 500 का जो डेटा है वो 200 है,
हम्म
और इसका जो डेटा क्या है, 600 का डेटा क्या है, 300 है। ये हो गया ट्री।
हम्म
ये सारा मेमोरी एड्रेस ही तो है, बस उसको ऑर्गेनाइज कर रहे हैं अलग अलग तरीके से। ये बन गया ट्री। इसको नहीं ऐसे स्टोर करके आप ऐसे लीनियरली स्टोर कर देते तो वो दूसरा मेमोरी एड्रेस हो जाता।
हम्म
आप इसको अगर ऐसे स्टोर कर देते एक एरे में, यहाँ पे आप डाल देते 100, यहाँ डाल देते 200, यहाँ डालते 300, तो 100 किसको पॉइंट कर रहा है, इम्तियाज को। 200 किसको पॉइंट कर रहा है, सुनील को। 300 किसको पॉइंट कर रहा है, अरुण को। तो ये हो गया एरे।
हम्म
इसी एरे से आप स्टैक और क्यू भी बना सकते हो अगर आप चाहो तो, लेकिन स्टैक और क्यू का यहाँ पे कोई यूज नहीं है क्योंकि हम एक रिलेशनशिप
मुझे
डेटा
लगता है
बना
कि
रहे हैं।
ये जो हम ट्री यूज करते हैं लार्जर सेट के लिए करते हैं क्या, लार्जर कुछ डेटा रहेगा उसमें, ऐसा
ऐसा
कुछ
कुछ
भी?
नहीं है। नॉर्मली जब हम लोग डेटा स्टोर करते हैं तो उसमें ऐसा ये सोच के नहीं करते कि कम डेटा होगा ज्यादा डेटा होगा। जो भी हम बनाते हैं वो ऐसा बनाते हैं कि उसमें कितना मर्जी भी डेटा है वो उसको हैंडल कर सके। बात डेटा के साइज का नहीं है, बात डेटा के नेचर का है कि आप क्या रिप्रेजेंट करना चाह रहे हो।
हम्म
So
सर
है ना।
Ram, if I understood correctly, Navneet is
हम्म
asking what
हम्म
kind of advantages we'll get if storing data such type of organized.
दैट्स व्हाट आई एम टेलिंग यू, यू विल गेट
So
एडवांटेज ऑफ व्हाट यू आर। Advantage is based on what you're trying to do. I'm trying to find the relationship between what I want to store. I basically want to go to Imtiaz and find
right,
out who are the people who are reporting to Imtiaz.
true.
Correct? So if I store it like this, am I getting that information?
Yeah, that's the easiest way to transform
This
and
is
go and
this
get
is
the
the
data.
easiest and convenient way to store this.
Okay,
You can say that, oh, we could have also stored it as a hash map, dictionary.
right.
Valid, we can do that. But this is going to be, but here, as you move forward, you will see that there are other advantages also.
Okay.
But based
So
on what we have
processing.
studied, based on what we have learned, it is very, very evident that if I want this relationship, I cannot achieve that using linked list, I cannot achieve that using array.
Got it.
सर मेरा एक क्वेश्चन है, क्वेश्चन
हम्म
नहीं है सर, वो आपने क्या पूरा नोटबुक और नोट्स रिसोर्स में डाले हैं क्या? मैं
डाले
देख
है ना,
पा रहा था। नहीं, स्टैक्स वगैरह के,
सब
स्टैक्स का
कुछ
मैं
डाला,
नहीं देख पाया,
सब कुछ
मुझे
डाला
तो
हुआ है।
नहीं दिखा। स्टैक्स का नहीं दिखा, डबल लिंक लिस्ट का नहीं दिखा, सर्कुलर लिंक लिस्ट का भी नहीं डाला।
सारा है। यहाँ पे देखो, स्टैक का है नोट्स, क्यू का है नोट्स, इंट्रोडक्शन का है नोट्स, तो सारा तो है यहाँ पे।
कहाँ पे? ये
देखो ना,
ड्राइव में है?
ड्राइव में है।
इसका तो एक्सेस ही नहीं है मेरे पास शायद।
नहीं नहीं, ये तो ग्रुप पे शेयर किया हुआ है ना, सब लोग इसको ही एक्सेस करते हैं।
ओ,
मैं डाल देता हूँ चैट में, आप यूज कर लेना।
ठीक सर। ये, और दूसरा ये बात कि सर आप जो ये टूल यूज करते हैं स्केचिंग के लिए, क्या
हाँ हाँ,
क्या क्या यूज करते हैं, कौन सा एप्लीकेशन यूज करते हैं और कौन सा पेन यूज करते हैं, क्योंकि ये अच्छा है मतलब।
ये वाला सॉफ्टवेयर आप पूछ रहे हो,
हाँ हाँ।
ये गुड नोट्स है।
अच्छा,
गुड
क्योंकि
नोट्स
आप
है।
तो ये
मैं
इसको
ऐसा कोई फिक्स नहीं है, मैं बहुत सारा टूल यूज करता हूँ। ये गुड नोट्स यूज कर रहा हूँ, कभी कभी मेरा मूड होता है तो एक्सकैलिड्रॉ यूज करता हूँ, कभी वन नोट भी यूज करता हूँ, नहीं तो मीरो बोल के एक होता है वो भी यूज करता हूँ। तो
लेकिन ये थोड़ा अच्छा लग रहा था क्योंकि
ये
आप इसमें
इसलिए
जो,
अच्छा लग रहा है क्योंकि इसमें मुझे फैसिलिटी मिलता है पीडीएफ में कन्वर्ट करने के लिए। और
इसके बाद
बाकी
आप जो ये इरेज टूल यूज करते हैं ना, जहाँ से मतलब वो ये जो शेप्स के बगल में है,
कहाँ पे
शेप्स के बगल में, टॉप में जहाँ टूल्स वगैरह हैं, शेप्स के बगल में, हाँ ये वाला, इसके बगल में, लेफ्ट
ये
लेफ्ट लेफ्ट
ये
ऑफ
वाला।
दैट, हाँ ये वाला।
हाँ
आप कहीं से ऐसा सर्किल करके उसको मतलब
हाँ
कॉपी पेस्ट कर पाते हैं।
हाँ हाँ हाँ
हाँ ये वाला टूल, ये वाला फीचर बहुत बड़ा अच्छा है।
हाँ, ये पेड है एक्चुअली। तो
ओ, इसलिए
लेकिन फ्री वाला भी, ये कोई बड़ा चीज नहीं है, बहुत सारा टूल अवेलेबल है मार्केट में।
नहीं
Ram,
बहुत।
हाँ,
और पेन क्या यूज करते हैं, पेन?
पेन बहुत सारा आता है मार्केट में, मेरे पास वैकॉम का है।
वी
ये
एस
देखो, ये देख रहा है कैमरे में ऐसे
वी
yep,
एस सी ओ एम
WACOM।
अच्छा, ठीक है।
एक मिनट दिखा देता हूँ। वैकॉम पेन टैबलेट, कभी कभी मैं आईपैड यूज करता हूँ, कभी वैकॉम यूज करता हूँ।
अच्छा, मतलब आपके पास पैड भी होगा ना?
हाँ, ये ऐसा पैड होता है।
अच्छा, तो ये पैड और वो दोनों संग
हाँ,
संग
इस
में
पे
आता
ऐसे
है?
हाँ, इस पे ऐसे लिखता
अच्छा, ये ब्लूटूथ से कनेक्ट होता है या फिर वायर्ड होता है?
है। ये वायर्ड होता है, ब्लूटूथ वाला महंगा आता है थोड़ा, उसमें
ओ,
लैग लैग आ जाता है थोड़ा सा, तो
तो
वायर्ड वाला बेस्ट है।
ये दोनों पिन और ये पैड अपना वेकम का ही खरीदा है?
हाँ, वैकम का सेट आता है।
अच्छा, ठीक है,
हाँ,
ठीक
वैकम का आता है, एक्सपी पेन का भी आता है, बहुत सारा है।
है, ठीक है, थैंक यू।
Sorry to interrupt, Ram. Just I am the new. This is the first class for me. Okay.
प्लीज टेल मी योर नेम।
My name is Imtiaz.
इम्तियाज, हाय इम्तियाज।
Yeah. Whatever till now it's going all the nodes, whatever the things, drive access, whatever the access, right? Is there any like a kickoff start notes somewhere around we can follow and get it done?
All the recordings are there, you can watch the recordings, all the notes are available, everything is available.
But the content accessibility, as Imran mentioned, right? So just now Imran is asking, you mentioned is one of the group we already shared, right? So what is that group? If I want to join that group,
There's the WhatsApp group, no?
okay, it's a WhatsApp. Okay.
All the people who are in this study group,
Mhm.
all the people who are in this class, they are part of a WhatsApp group.
Okay.
So that WhatsApp group, all the discussion about the classes and everything happens in that group.
Yeah.
So
Fine,
you
Ram.
can, all
So
the links,
actually,
everything is shared in that group. If you ping in that group, other people will quickly share it. And otherwise, important things are also pinned.
okay. Yeah, good to have. But still, sorry, I haven't catch up many of the things. Let me go through that. I'll catch up.
You go
If
through
any,
everything. If you face any difficulty, you let me know. I can also help you. Otherwise, if you post in the group, other people will also help you.
yeah, that
Don't
would be
worry
the great.
about it.
Yeah. Thank you, guys.
Yeah. Any questions, anywhere you are stuck, any difficulty you face, you can always post in the group. You can tag me. I will reply immediately. Otherwise, before the class, after the class, you can sit with me one on one also. We can spend time.
Yeah, I request you for today for 10 to 5 minutes, not more than that.
More
Just I
than
want to
that,
go
how much?
through.
Half an hour also you want? I will sit with you. No problem.
No problem. Thanks.
Okay, after the class. But you
Yeah.
tell me that you want it. Otherwise, I wait you normally for 5-10 minutes. If someone is asking, then only I wait further.
Yeah, that's great.
Okay, cool. Okay, we'll start, guys. Okay, before tree traversal, few more things I want to discuss, which I forgot. Again, not very important, but just for your knowledge, that there are some more terms which are around types of trees. Okay, so there are some terms here. Again, no need to memorize at all. Nobody will ask you. But just for your familiarity, there is something called as a perfect binary tree. Then we have complete binary tree. Okay. These two are important terms. There are others also, like a skewed tree. So we'll just quickly understand the meaning of these things and then we will move ahead with important topic of traversal. Okay. So see, if I'm making a tree like this, okay. So here you see all the leaf nodes are at the same level. All leaf nodes are at same level. Okay. All leaf nodes are at the same level and all levels are filled. This is called as a perfect binary tree. Or you can say that all levels are filled means all internal nodes have two children. Okay. This is the node. This is the tree like that. If I make it like this, if I take this tree, bring it here, and if I delete this node, then this is not a perfect binary tree. This is not a perfect binary tree, but this is a complete binary tree. We can say this is a complete binary tree. Complete binary tree is all levels are filled. Guys, are you following? All levels are filled except last level. Last level may or may not be filled. Okay, so all perfect binary trees are also complete binary trees, but all complete binary tree will not be a perfect binary tree except last level. Last level also should be filled from left. Okay, so you can see that this tree, this is the node, it is having two children. This node is having two children and this node is having one children. One child here is missing, but all the nodes are filled from the left. Okay, this concept will be applicable when later on when we are learning about heaps. Okay, if we ever having this tree like this instead, where this node is not there, okay, then this is not a complete binary tree. Because left side is empty and right is filled. Okay, nobody is going to ask you these definitions, but just keep in mind that these are two varieties. So perfect binary tree will be filled and all levels will be filled and all leaf nodes will be at the same level. Like this. By looking itself, you will see that, okay, this is perfect. And complete binary tree is complete where it is filled in from left to right and all levels should be filled except the last level, and in the last level also all the nodes should come from left side first. Or you can say here all nodes should be as left as possible. last level nodes should be as left as possible, as left as possible, but not last level nodes, all nodes. These two things are clear, guys. Now, what is a skewed tree? Skewed tree, I gave you the example. When a tree becomes a linked list, you're having this type of tree. When you have this type of a tree, then it becomes a skewed tree. ठीक है, all of you are clear till here, guys? Then comes the most important topic. This is where all your problems are going to come from in trees. So till now we were just doing familiarity with trees, but this is more from the problem solving aspect, the type of problems that we are going to be doing. And today also we'll solve some lead code problems around trees. Till here, guys, does anyone have any confusion or doubt? Anything that you have not understood? Anyone having any question or doubt till here? Okay, we'll move ahead. So tree traversal. So what do we mean by tree traversal? Or in general, what do we mean by traversal? So if you remember when we were talking about array or like this, I told you that array is a linear data structure. So that's why there is no question of ambiguity in the traversal. Okay, you will have values like this and you're going to traverse like this, like this. Or you can traverse, you can have index, you can go there. Okay. Or if you have a linked list, we learned how to traverse a linked list. There is no ambiguity in that, right? You have some nodes and you say next, 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 you go to the next node, right? And similarly, you have stack and queue also. There is no ambiguity in that. If you have a stack also, there is no ambiguity. So this is traversal, no hierarchy. Okay, sequential traversal. Linear traversal. But when we talk about trees, if we talk about trees, and imagine that these are some relationships in your mind. Just try to imagine that these are maybe parents and children. So 10 is the parent, 10 is having two children, 20 and 30, 20 is having two children, 40 and 50, 30 is having two children, 60 and 70. Okay. So if I say I can traverse, if I want to traverse it, I can traverse it like this. I can say that first I will go to 10, then I will go to 20, then I will go to 30. Okay. Then I will go to 40, then I'll go to 50, then I'll go to 60, and then I will go to 70. Is this a valid traversal? Can I traverse it like this? Guys, yes or no?
Yes, if you go from left to right, means parent, then child, left to right, yeah.
Okay, this is one type of traversal. Okay. Can I also say that I want to traverse in a different way, where I want to say that I want to start with 40, 20, 50, which is this node, Okay, then 10, and then 60, 30, 60, 30, and 70. Okay, so how did I traverse? First, I went like this.
From the leaf, yeah.
First, I traversed like this. Then I went here, and then I traversed like this. So 40, 20, 50, 40, 20, 50, like this. So this node I traversed, then I went to this node, and then this node I went like this. This is also one type of traversal.
ये
I can
traverse
also
means
So it's kind of the backward traversal, right? Can it support on both traversals, sir?
wait. I will give you many, and then I will. Right now, I have not organized it. I will organize it and I will tell you. Right now, I'm just giving you all possibilities. Can I also traverse like this? Can I say 10, 20, 40, 50, and then 30, 60, 70? How did I traverse? I said 10. Who is the child of 10? 20. Who is the child of 40? Who is the child of 20? 40. Who is the other child of 20? 50. So I went here and here like this. Did you guys see? I went here like this, and then I went here like this. 10, 20, 40, 50, 10, 20, 40, 50, and then 30, 60, 70, 30, 60, 70. Or you can say that, suppose these are friends. So who is the friend of 10? 20. Who is the friend of 20? 40. Who is the other friend of 20? 50. Okay. Then we'll go back and then ask who is the friend of another friend of 10? 30. Who is the friend of 30? 60, and then 70. Here, how did we do? We said, okay, how many children, how many friends does 10 have? 20 and 30. Then 20 like this. So we went like this. 10, then 20, 30, 10, 20, 30, then 40, 50, 60, 70, 40, 50, 60, 70. So we went like this. Okay, this one. And in this too, what we are doing is we are going like this. Can you see the traversal pattern, different patterns?
so there are many possibility, no? Or
There are not many possibilities, there are limited possibilities. Okay, then possibilities which will have some structure to it. Okay, then I can also say that I can do it like this. I can say one more traversal I can do, which is 40, 50, 20, 10, 60, 70, 30. अभी आपको लग रहा होगा रैंडमली मैं कुछ भी नंबर्स लिख रहा हूँ, बट इसका मैं स्ट्रक्चर बताऊंगा. ये क्या कर रहे हैं? ये और ये ऐसे गए, ये नोट, ये ट्रैवर्सल हो गया, ठीक है. फिर इसमें गए और फिर ये ऐसे ऐसे, यहाँ से ऐसे, फिर यहाँ से ऐसे, ये. And you will see that this is having a pattern, and here you will see the recursive pattern, but I don't want to go to recursive, but I want to formalize these. Okay, so if I talk about these traversals, then these three traversals, these are depth first traversal, and this is the most important concept that you have to learn. There is nothing as important as this traversal. Everything in trees and graphs is related to traversal. Not everything, but most of the things. Okay, and this we will call it as a breadth first. Okay, this is called as a.
सर आपने ये जो ट्रैवर्स किया है 40, 20, 50, लेकिन जो स्ट्रक्चर में है वो तो वन डायरेक्शनल दिखा रहा है कि 10, 20 को पॉइंट कर रहा है, 20, 40 को पॉइंट कर रहा है और 20, 50 को पॉइंट कर रहा है.
वो ठीक है, वो ठीक है, बताता हूँ मैं, रुक जाओ। दिस इज BFS एंड दिस इज DFS। हियर मैंने ट्रैवर्सल लिख दिया है, बट ये एक्चुअली ट्रैवर्सल नहीं है, इसको हम लोग सर्च बोलते हैं। ठीक है, तो डेप्थ फर्स्ट सर्च पहले पढ़ते हैं हम लोग। डेप्थ फर्स्ट सर्च, यहाँ पे ध्यान देना, ये इंपॉर्टेंट चीज है। ठीक है, high level depth first search. What is depth first search? High level, it says depth first. Okay, if you remember, we were doing one podcast in our earlier, before we started in the first um, in the first class of this course, and I told you that there is a depth interview and there's a breadth interview. Okay, or when we are learning, we learn depth and we learn breadth. What's the difference between depth and breadth? Or what is depth first approach and breadth first approach? Can someone explain? The visualization in your mind is more important. Okay, code can come later. Code you will be able to write. Suppose you are studying data science. Okay, so in data science there are several fields. For example, there is, you have to study about probability, then you have to study about programming, you have to study about ML. Okay, you have to study about DevOps. Okay, so within probability you have to study about continuous probability, descriptive probability. You have to study about inferential probability, not probability, let me call it statistics. Okay, you have to study about probability. Okay, programming you have to study about maybe Python, you have to study about SQL, you have to study about some other things. ML you have to study about maybe supervised learning, unsupervised learning. DevOps you have to study about maybe cloud, you have to study about maybe Hadoop, things like that. Okay, then within probability you have to study a few things. Within descriptive study you have to study a few things. Within inferential statistics you have to study a few things. Python you have to study many things. SQL you have to study many things. ML you have to supervise, you have many algorithms. Unsupervised you have many algorithms. Okay, cloud you have many things. Maybe you have AWS, you have GCP, many things. Hadoop you have Spark, you have many things. Okay, you have CI/CD. There are many things are there. Okay, and then within whatever comes here, within that there will be further some topics. Okay, all of you are able to understand? So like this, your learning structure will be there. Now, some person can say, some person can start preparing and he will say, okay, I will study data science and I will start with statistics. And when he is starting to study statistics, he will say, no, I will start with probability. And with starting with probability, he will go into one specific type of probability. And then within that, he will go to some specific type of that. And he will go to some specific type of that. So he is studying like this. And until he will reach the end of it, he is not going to go to programming. So he's going deep into the subject. Okay, he's going to deep into that subject. Or if he's studying programming, he will go to programming, he will go Python, he will study this, and he will keep going like that. Okay, this is one approach. All of you understood what I mean to say? There can be other person. There can be other person who will say that, okay, I want to study data science. I will study statistics. I will not go deep into it, and then I will study programming also. Then I will not go deep into it. I will go to ML also, then DevOps also, then CI/CD also. So I will cover this level first. Then I will go to this level. So I will study probability, then I will study descriptive, informative, little bit of Python, SQL, this, like this. I will cover these topics. So I'm covering the breadth. I'm covering the breadth. I don't have deep knowledge about anything. I don't have deep knowledge about anything, but I have breadth of knowledge. I know little bit about many things. Okay, so I'm going like this. So when you go level wise, this is called as level wise. then that is called as a breadth first. So depth first, breadth first is also called as, in tree it is also called as level order. Did you get the high level understanding, guys?
Means first we have got breadth first, then depth first, right?
दो
Breadth
अलग
first
अलग
means that upper layer.
upper layer नहीं,
No, means that slightly. So in top of the part.
मैं फिर से बताता हूँ. Suppose you are talking about some friends, okay? 10 has two friends. One is 20, other friend is 30. And 20 has other friends 40 and 50. And he has other friend which is 60 and 70. And he's having other friends which is 100 and 200. And I'm asking you to find out the network of 10. So all these are in network of 10. Okay. And I want to find out all of them. So what can I say? There are two ways in which we can traverse it. I can say, okay, 10. Now, who are the immediate friends of 10? I will say, okay, 20 and 30. 20 and 30. So this level I have completed. 10 ka immediate friends level I have completed. So this is one level. This is one level. 10, 20 and 30. Then I will say, okay, for 20, who are the friends? So I'll say 40 and 50. Okay. And then for 30, who are the friends? 60 and 70. Can you see that I'm going level by level?
Yes.
60 and 70. So I went 10 and then I went this level. Then I went this level. Then I will say, okay, for 40, who are the friends? So for 40, 100 and 200 are friends. Do you understand level order traversal? Now, what is another way? Another way to do it, which I was trying to discuss, is someone says, okay, 20. Who is the first friend of 20? 20. Then who is the friend of 20? After 10, I'm going to 20. Now, who is the friend of 20? I'll say 40 is a friend of 20. Fine, 40 is a friend of 20. Then who is a friend of 40? It's 100. Now, this depth I have traversed. Like this, I have gone. Now, after going like this, there is no such thing, nothing after 100. So I'll go back to 40 and I'll say, okay, who was the other friend of 40? 200. So I'll come here and I will say, after 100, I will say 200. Then I'll go back to 20. So this much I have already traversed. Now I will go to 50. So this much I have already traversed now. I'll go back to 10, 20, this is done. So I'll go to 30. Okay, I'll go to 30. 30 ke baad 60. 60 is done. I'll go back to 30 and I'll go to 70. You see how I'm traversing this? Is there a difference? Can you see the difference? Here I'm traversing like this. I went like this, like this, like this, then like this. So full depth is covered. This whole depth is covered. Then like this. So this whole depth is covered. Then I will go back like this, like this, like this. So when we talk about depth first search, I hope you got at least some intuition of depth first search. There are three varieties of depth first search. The first variety is called as in order traversal. Pre-order, let me say. Pre-order traversal. In pre-order traversal, what we do, we go from root, okay, to left, and then we go to right. Root, left, and right, which means root, then left, and then right. Root, and then left, and then right. Did you understand this? 40, 100, and 200. So if you have to do a pre-ordered traversal of this tree, then what we will do? Pre-ordered traversal of this tree. First, we have to do root. So, what is the root? 10. Guys, are you following? Or lost? Let me take a simpler example. Guys, high level depth and breadth search is clear to you or not? Are you able to relate it? No, to in your mind at least what I'm talking about? Saying 10, 5, 20, 3, 7. And I will take 15. Okay, so you have to do a pre-order traversal. What do I mean by pre-order traversal? You see, imagine the shape in the mind. Root. What is the root? 8. And then we have to go left. So left we have to traverse this one. So we have to do traversal of this tree. If you have to do a traversal of this tree, then how will we do? We'll first do 5 because root, and then left 13 and then right 7. So ये tree का traversal हो गया. Root 8 and then left root and then left and then right. Right have to do. So right is what? 20 and 15. So here again we have to do traversal. So first what will come? 20 and then 15. Okay. So what will be the pre-order traversal for this? Can we say 8, which is root, and then left? So left subtree ka traversal will be what? Root, left and right. 15, 7 and 13. Correct? 13 and 7. And then we will do right. So right is what? 20. So we'll do 20 and then left, which is 15, and right we don't have anything, it is null. So null we will leave it as it is. So this is the pre-order traversal. Eight, 5, 8, 5, 13, 7, 20, 15. Imtiaz, what you have given is correct.
Means you are going to first depth approach, depth first search. So okay. So we're going 8, 5, 13, 7, then 20, 15. Okay.
ऐसे गए हम लोग 8, 5, 13, फिर यहाँ 7 और फिर 20, 15. 15 के बगल में कुछ रहता तो ऐसे भी जाता है. ठीक है. The second variety is called in order traversal. In order traversal is left, then root, and then right. Okay, left and then root and then right. How will we do? So I'll take this example again. See, it's first we have to start with 8. So we have to do level order traversal of in order traversal of 8. Okay, so in order to do traversal of 8, what we have to do? First we have to traverse the left. First we have to traverse the left. So left, what we have? Left we have this tree. This tree is there. So we have to traverse 5. How to traverse 5? We have to traverse the left node. So 13. So we will start with 13, then go to root. So 13 ka root is 5. and 13 ka right is 7. So what we have done? We have traversed the left part. Then we will go to the root part. So root is what? 8. And here you will see the recursive nature, because here I've just put 2 levels, but when you have more levels, you will see how recursive nature will come into picture here. Okay, 13, 5, 7, then 8, and then we'll go back to right node. So for right node, again, left root. So 15, 20, and after 20, there is nothing. So you can see this is what? This is the right side. So here I can say this is left subtree. This is the root. And this is the right subtree. Did you guys understand? Are you guys following?
Yes.
Okay.
So earlier I thought it was to be first we'll go with the left to root, then root to right. But here you can see right to root है again.
Right to root नहीं है ना, left
यहाँ
to root
पे
ही तो है. कैसे गए देखिए?
2015.
13, 5, 7. 13, 5, 7. Left, root, right.
Right.
तो ये पूरा लेफ्ट हो गया बड़े वाली ट्री का. Then we went here. So this is the root.
Right.
Then we have to do the right subtree. So for right subtree, again we have to follow left root right. So left root right. 15, 20. 15, 20.
Okay. Got
So
it.
we did like this. We like this, then like this, and then like this.
Got it.
Okay. Now if there are more nodes here, if there are more levels, then you have to follow the same pattern. But here I'm showing you just first time you're seeing, that's why I've just put 2 levels, but there can be more levels. Okay, but high level, if you see it, it is the pattern is going like this. You are spreading like this, like this, like this, then like this, then like this, then like this, then here like this, like this. This is the depth first. Now depth you can do in many ways. You can go like this, or you can go like this. So here in order traversal, we are going like this. Direction is changed, but it is still depth. The nature is depth. I told you there are 2 varieties. One is tree. Oh, I didn't write. Oh, yes, I wrote here. So first variety is one variety is depth first and one variety is breadth first. So we are only learning about depth first. Depth first itself has 3 varieties. First is pre-order, second is in order. The third is, you see how you will remember it. You can remember it from the position of the root. If the root is coming first, then it is pre. Root is coming in the middle, then it is in order. And root is coming last, then it is post order. So pre, in, post. You can remember like that. So third is post order. So post order traversal will be how? Root will come last. Then you will have left, then right, then root. You see the beauty of this one. And you will be able to relate it to some operations that we do very often. That suppose you have a node here, like 10, 20, and 30, suppose. Or you have some file structure. Suppose you have music folder. Inside music folder, you have Indian music and you have jazz music. And in your operating system, suppose there is a functionality that if the folder is containing subfolders, then you cannot delete it. Okay, you can delete only empty folders. Then what you will do? First, you will delete this one, then you will delete this one, then you will delete this one. Correct? And if you have other folders also, for example, games. Okay, and here you have maybe GTA, and here you have FIFA. and these two are further subfolders of files. So if you want to delete files, you have to delete games. In order to delete games, you have to first delete GTA and FIFA. So this you have to delete, this you have to delete, then you will delete this. Then you will delete this, then you will delete this, then you will delete this, then you will delete this. So how are you going? You are going delete, sorry, delete left, then right, like this, and then delete this. Okay. Then you come here, delete this, and then delete this. When these two are deleted, then you are able to delete this. So you can see the traversal. You're going like this, then like this, and then like this. Did you guys follow? कहीं समझ में आ रहा है कि नहीं? Okay, this is one application of in order traversal. So when we want to delete a tree node, we will delete using in order traversal. Later you will see in the
डिलीट क्यों
problems.
करते हैं इसमें?
डिलीट क्यों करते हैं? आपको जो आप जब कुछ बनाओगे तो आपकी मर्जी है, आप कभी कभी डिलीट भी करना तो चाहोगे ना किसी चीज को. So how will we do post order traversal? If we want to do post order traversal of 8, so we'll go and do post order traversal of left. If we want to do post order traversal of left, how will we do? We'll go to left, right, and then root. So 13,
7, 5, 8.
7 and 5. This is my left. Then I will go to my right. So right I have what? 15 left. Right is nothing. Then root 20. And then after this is left and this is right. And after that 8. ठीक है? This is my left subtree. This is my right subtree. And this is my root. Within left also you see I have left, right, root. Left, right नहीं है, root. Root, main root. Guys, all of you are following? Now, if I ask you to implement this, pre-order, in-order, post-order, or for example, depth first in general, then what data structure do you think you can use? Pointer is not a data structure. Come on.
Yeah, linked list. Sorry.
How?
Linked list left and right with the head and front and rear.
Doubly linked list. How?
Yeah.
Doubly linked list. How? 8, 5, 20, 13, 7, 15. 8, 5, 20. Let me copy this. Okay, and let us try to do a dry run of how we will do. Okay, I want to do a traversal of this. How will we do traversal? Try to think, try to relate it to some data structure that you have read. Okay, so you will read 8. Okay, and after 8, suppose you are reading 5. After 8, suppose you are reading 5. Okay, then you want to perform some operation on 5. Or you want to perform some operation on 8. You want to perform some operation on 5. Okay, in order to perform some operation on 5, what you will do? You will go to 13 and you will go to, either you will go to 13 or you will go to 7. Suppose you are going to 13. So you are referring to the last element that was accessed. What data structure that you have learned so far is fitting into this description? Tell me. Suppose I'm doing pre-order traversal. What is pre-order traversal? Someone tell me again how we'll do pre-order traversal. Pre-order was what? Root,
left and right.
root, left and right. So root is what? 8. Left is what? 5. Okay. 5 के बाद 13. 13 के
7.
बाद 7. And then right. So right we will go to root again 20 and 15. How can we achieve this? Can we use a stack?
Stack last and first out. Yeah. No.
Suppose we take a stack. Okay, and we create our result here. Everything that you've learned so far is going to come in useful now. This is our result. Okay, we put 8 here. Okay, 8 here, and we will put 8 in our stack, or we will not put here. We'll take out 8 and we'll put it in our stack. After that, what we'll do? We'll take out 8. Okay, and we will ask. Okay, we'll take out 8 and we'll put 8 in our result, and we'll ask who are the children of 8. Who are the children of 8?
5 and 20.
5 and 20. So can I say put 5 here and 20 here like this? And can I say that my 8 is processed, the job of 8 is done? Then again I will pop from stack and I will take out 20. But is this going correct? Because I want to process my
Left side
left
one.
node
No.
first. I want to process my left node first. So it should go ulta. Okay, when I was having 8, I will ask who are the children. I will get 5 and 20. I will first push 20 and then I will push 5. Ulta I will do. First right and then left. Okay, then I will take out 5 and I will ask, okay, boss, tell me who are your children. So I will get answer as 13 and 7. If we are at node number 5, can we find out who are the children? Yes, we can find out. Node dot left, node dot right. I will get 13 and I will get 7. Okay, again I will do the same thing. I will put
7 we need to push it, right?
I will put 5 in the result. Okay, and I will put 7 and 13 back in the stack. Then what we'll do? Again, we will pop from the stack 13. We'll say who are your nodes, who are your children. So it will say null and it will say null.
You can add the result, right? Because since there is no children.
So we'll not do anything. We'll put 13 here and the job of 13 is done. Then what we'll do? We'll pull out from the top of the stack 7. Okay, we'll ask who are the children of 7? No one. So we'll put 7 here and job is done. So till now, how much traversal we have done? We have done 8, 5, 13 and 7. This much we have done. Now what we have to traverse? We have to traverse 20. 20 is only left in the stack. So we'll take out 20. We'll ask who are your children? I will get the answer as 15 and null. Okay, so I'll put 15 back in the stack and I will put 20 here and job of 20 is done. Again, what I'll do? I'll take out the top of the stack 15. I'll ask who are the children? Null and null. Nothing. So nothing to put in the stack and 15 will go here. So have I done the pre-order traversal here? Tell me. Can we write this? Can we write the pseudocode for this?
इसमें कितना टाइप का ट्रेवर्सल होता है?
कितना टाइप का ट्रेवर्सल होता है? अभी तो डिस्कस किया ना, 3 होते हैं. प्री ऑर्डर, इन ऑर्डर, पोस्ट ऑर्डर। ये
हम्म।
सिर्फ डेप्थ फर्स्ट हुआ, एक ब्रेथ फर्स्ट सर्च भी होता है जो अभी डिस्कस नहीं किया है। ठीक है, कैन यू राइट द कोड फॉर दिस गाइस? व्हाट वी विल डू, सो व्हेन वी आर ट्राइंग टू डू पाइथन implementation of the traversal, or generally in Python traversal of trees, common questions that you will get will be around tree traversals. In tree traversals, you will find DFS. In DFS, you have three categories: pre-order, post-order, and in order. And you will have BFS. You will have questions related to height, depth of a tree. Okay, comparing a tree, views of the tree, left view, right view of the tree. Many such questions, but mostly the approach that you will do will be two types of approach will be there. One will be iterative, other will be recursive. So recursion we have not learned so far, but when we are learning about these trees, I will also write recursive code so that by using itself you will get familiarity with what is recursion. Okay, then separately also we'll spend some time on recursion, but recursion as and how we are learning itself you will learn. While applying itself you will learn. Okay, recursive approach is very, very important in trees. Most of the problems, or almost all the problems you will see will be recursive. The same recursive code can also be written in iterative. Okay, but recursive code will be more readable and it will come intuitively. But recursion is takes little bit of time to getting used to. Okay, so we'll do both the approaches.
सर ये लेफ्ट व्यू राइट व्यू ऑफ अ ट्री क्या है?
लेफ्ट व्यू राइट व्यू ऑफ द ट्री मतलब है कि ऐसे ट्री बना दिया, करेंगे जब प्रॉब्लम सॉल्व तब आ जाएगा आपको। अभी जैसे यहाँ पे ऐसे खड़े हैं, आपसे पूछेगा कि अगर ये एक आदमी यहाँ खड़ा है और ये ट्री को देख रहा है तो उसको क्या दिखेगा? उसको कौन कौन सा नोट दिखेगा? एक आदमी यहाँ खड़ा है और इस ट्री को देख रहा है तो उसको क्या दिखेगा?
लेफ्ट साइड के सिर्फ नोट दिखेंगे।
उसको ये सारे नोट्स दिखेंगे,
हम्म।
है कि नहीं? अगर यहाँ पे ये नोट नहीं होता तो क्या दिखता उसको? ये सारे नोट्स दिखेंगे, ऐसे दिखेंगे, है कि नहीं?
गॉट इट, गॉट इट।
तो ये कैसे निकालेंगे हम लोग? ये जो पैटर्न है ये कैसे निकालेंगे हम लोग? क्या मैं ये बोल सकता हूँ, क्या मैं ये बोल सकता हूँ, कैन आई से दैट फॉर एवरी लेवल द फर्स्ट नोड ही विल बी एबल टू सी, this is the node first in its level, this is the node first in its level, this is the node first in its level, and this is the node first in its level. So this is what, this is nothing but level order traversal का एक use case. If you are seeing it from here, then can I say that he is going to see the last node of every level? So what will he see? He will see like this. He will see this much. So last node of every level he will be able to see. So if you know level order traversal, till now we have not discussed breadth first, but if you know level order traversal, then he will see that. Then you will see questions like inverting a tree, invert tree, copy tree. Okay, traversal tree will be convert a tree to an array like that. Okay, and height and depth, path based, path based. Okay, longest path, shortest path. So this will all be like real life application of how trees are structured. Okay, similarly in graph also, you will have like some nodes which will be connected. Okay, some salesman has to travel these locations, or suppose this is a map or something like that. This will be a graph like this. And you'll say what is the shortest path from this node to this node. Okay, so someone can say that we can go like this also. We can go like this also. We can go like this also. So which is the shortest path? So you will see all those examples will come as a result of these tree traversals. Not tree traversals, it will be graph traversal, we'll see, but the idea will be very similar. It will be a depth first search and breadth first search. And these questions are very, very commonly asked. And in all the solutions, you will see that there's a pattern, that you will see iterative approach and you will see recursive approach. So we'll talk about both. So here what I've shown you, this was a iterative approach. I will talk about recursive also a little bit later, but right now just I'm giving you the initial flavor. Okay. So if I take this and if we try to write a pseudo code for this, and then we'll try to solve the lead code question also, because this is a lead code question also. Guys, till here, is everyone clear? If you have understood till here, then we are done with the theory of general trees. I have to do a little bit more theory of binary trees. After that, your tree theory will be complete. We'll start solving questions one by one.
Are we coding for all the three, pre, post, and in order?
Everything we will code. Whatever we are discussing, everything will be coded. बट यहां तक सबको समझ में आ गया कि नहीं, वो बताइए. ऐसा कोई चीज है जो अभी तक नहीं समझ में आया? इसका कोड लिखते हैं प्री ऑर्डर का, ठीक है. What did we discuss in this?
Root first, left and right.
वो तो ठीक है, कोड में क्या, प्री ऑर्डर ट्रैवर्सल, iterative approach. Okay. Later on, I will write the same code using recursive approach. So iterative, pre-order traversal, iterative. What we'll do? First, will we create a stack? ठीक है, स्टैक बना देंगे. स्टैक में रूट को डाल देंगे. Okay, initially we'll start and we'll put one result. Result will be empty list. Okay, then what we'll say? We'll say while stack. Okay, we'll take out the node. Node is equal to stack.pop. So here we have 8. We'll pop it, we'll take it out. And then we'll ask who are the children. So first we will put this 8 in our result. Correct, no? We'll put this 8 in our result here. We're putting that. So we'll say here, because why we'll put it in the result? Because we have to do root, then left, then right. Correct? So if you think that first the root will go and then not left, but the traversal of left will go. Okay, so first 8 will go, then 5 will go, but 5 will not go. Traversal of 5 will go. In pre-order traversal, first 5 will come, but in other traversals, 5 may not come. First 13 may come. Are you getting it? Getting the point? So we'll say if node dot right. First, we will push the right node because we want to pop the left node first. That's why we'll push the right node first. ताकि लेफ्ट ऊपर रहे, ताकि लेफ्ट पॉप हो जाए. We'll say stack dot push node dot write. Okay, and if node dot left, then stack dot push node dot left. Are you guys following this? This is the algorithm for pre-order traversal. Here I'm saying push, but you can say append because this is actually a list. And we will, in the end, we will return result. So try to imagine what will happen in this. Okay, so this is, we'll say, visiting the node.
No, adding the root element to the result.
Sorry?
First time when you pop your adding the root, right? Popping the root.
Popping the root, correct. That's why I added root first. Do you want me to do a dry run of this?
सर आप रिजल्ट में अपेंड भी तो कराएंगे
Yes,
ना?
yes, yes.
You will append into the result.
Yeah.
Ram, one quick thing just I want to wondering to ask.
So sorry. एक line रह गया इसमें.
जी.
Now we need to add to the result, right? Which
Result.
first one you popped out. Yeah.
Result dot append. क्या append करेंगे? Node dot
Data.
value.
Oh yeah.
Data value जो भी बोल लो. Data बोल दो. Yes, tell me. Someone was saying something.
Yeah, myself, yes. Okay. Just I'm asking. So assume that you are calling stack that path, then you are taking result append, then node dot write. But somewhere around node will contain this entire lineage. Then only it comes to know node dot left, what was the value, node dot right. Where we are storing that here?
Come again, please.
The node dot right, node dot left. You are invoking this, okay? But
Node
somewhere
will be
around
there
node
available.
will contain.
Node will be, the tree will be given to us.
Okay. So you mean to say tree is the input for us?
Tree is the input for us. Or you can
Okay.
say the root is the input for us.
Okay.
Input given will be root. Just
What
like in
form
linked
of
list, just like in linked list, a head is given to us. So similarly here we will be given a reference to 8.
Okay.
So from 8 we can go to 5, 20, from 5 we can go to 13. We can traverse the entire tree if we have a reference of the root.
How the data will store to retrieve before that? It's a linked list?
No, it will be a tree.
Okay.
We will create a data structure called tree. I have not shown you how to implement a data structure, but it will be a tree. We know from linked list and all our knowledge, we can create a tree. We can create a node. We can create a class node. Okay, or tree node. And this node will have three attributes. One will be data, one will be left, and one will be right.
Okay.
Let me write it properly. I have not implemented that because it's not much needed. Plus, based on your knowledge, you should be implemented on your own if you know the basics. But we'll create a node. The node will have data, left, and right. And then we'll create a class called tree.
Okay.
Okay. And in this tree, you can add like node dot right, node dot left, then node dot right dot right, node dot left dot left. You can keep adding different nodes and you can create a structure like this.
Okay.
Okay.
So
And that structure will be given to us.
Okay. For this example, we are assuming this structure is already there and we are accessing that.
Yes. Always, whenever you are given a question, the given tree is not important.
Okay.
The algorithm in itself is sufficient. It says that if I am given a tree, which means if I'm given the access to the root of a tree,
Okay.
can I traverse it
Yes, we can.
using this algorithm? Now, which
Yeah.
tree, that is not important because it will work for any tree. I'm going to write a function. That function will accept a tree and it will give the traversal.
Got it.
So reference to this node class will be given to us.
Okay.
I'll show you in lead code when we do it.
Yeah.
But this line by line, this approach is clear.
Yes.
There's
Sir,
one
can
more
we do a
approach.
quick
Huh.
run, try run, keeping that numbers parallel to this code and see.
Sorry, please come again.
Can you put that code parallel to that diagram, which is numbers, which we are taking? That's, yeah.
8,
5,
8, 5, 20, 13, 7, 15.
Yeah. Can we do a quick try run?
You want to do, we can do. Wait one second. 8, 5, what was it? 20, 13, 7 and 15. Okay, so let us do a dry run. So first we will create our stack. So in our stack, we will have the root, which is 8, which is given to us. Fine. And we will have a result. So result is here. Empty. Fine. Now the question says while stack. While stack node is equal to stack.pop. We will pop the node. This 8 will come out. Okay. And we will say that result.append node.data. So here we will append 8. And if node.write is 20, then stack.push node.write. So we'll push 20. And if node.left 5, then we'll push 5. So what have we organized now? That we have kept track of 8 ka child is 5 and 20, and first we have to process 5. Okay, so job of 8 is done. Then again we'll go while stack is there. So stack.pop. So we'll pop 5. Okay, we will put 5 in the result. So we'll put 5 in the result. If node.write is 7. So we'll push 7. And node.left is 13. So we'll push 13. And job of 5 is done. Then again we will node is equal to stack.pop. So we'll pop 13. Okay. And we'll put 13 here. And we'll say node.left, node.right. Node.right is 13. Nothing is there. So we'll not put anything. Left also nothing is there. So we'll not put anything. So we'll put 13 in here in the result and our job is done. Next, again, we will pop 7. Okay. So 7 again, if node.right and node.left, both are not there. So nothing we will do. We'll put 7 here. And our job is done. 7 is done. And what is left? 20 is left. We'll take out 20. Okay. Does it have any right child? No. Does it have any left child? Yes. 15 is a child. We'll put 15. And 20 we will put here. And job of this is done. Then again we will pop out 15. Okay. So 15 is having any right or left? No. Only append. So we will do 15. So this is our traversal. Clear, guys?
It's clear.
Okay. There is also one more approach of this, which is recursive approach. So let me also try to write that. I hope you will be able to understand. After that, we'll write the code for that in lead code. 6:30 already. Okay. So I'll say pre-order traversal. I'll say recursive. Okay. Now try to think that when we are doing, guys, please pay attention. This one. Okay. When we are doing traversal, pre-order traversal, what did I say? I said root, left, and right. Correct? Yes or no? So we are doing, we are taking root, and when we are going to left, which means this tree, we are again doing a depth pre-order traversal on this subtree. Is it right? Is it correct?
Yeah.
So if we have a function called a DFS, okay, if we have a function called DFS, we know that this function does a DFS. How it does, forget about it. But we know that it is doing a DFS. Okay, then can we say that I want to do a DFS? Can we say that I want to take 8 and then I want to do a DFS on 5 and then I want to do a DFS on 20? Can I say that? And my job will be done?
Can you repeat it, sir? What your DFS on 5, then after that DFS on 20 is saying, right?
Yes. I'm saying that I'm having faith on this function that this function does a DFS. Okay. Then can I say that I will take 8, root 8, which is my root. Okay. And then I want to do a DFS on this subtree. I know how to do a DFS on bigger tree. So can I do a DFS on a smaller tree? I can do. So I want to do a DFS on this, and then I want to do a DFS on this.
Yeah. Yeah.
So my
Means,
order is going to be, I want to say that result dot append node. Okay. And then I want to do a DFS on node dot left. And I want to do a DFS on node dot right. Now you will say, what is this DFS? How we have not written this DFS, but forget that for a while. But if we have a DFS function, then can we do this?
yes, we can do. It's like a small tree. A small tree doing a small tree.
Yeah. If this node dot left, if this is having a further a tree, then further this function will take care of itself. So I will take this and I will define one function. I will write this function that this is only my DFS function, which takes a node. Okay. And it will append that node to the result. Okay. And then it will do the same DFS on the left and on the right. So this is the function DFS, which is using itself inside it. This is only recursion. Okay. And whenever we write a recursion, okay, we always have to think of a base case. Okay. What is a base case? The base case is that if my function reaches here, ये थोड़ा सा confusing लगेगा आपको, समझने में 2-3 बार लगेगा, but ठीक है. Okay. If I am doing a DFS on this node, which is null, suppose here I'm doing null. If we are doing a DFS on this node, then what should happen?
Empty. कुछ नहीं है ना.
The function will not do anything. So we'll say if not node, or we can say if node is none, or not node, whatever you want. If not node, then we will say if not node, then return none. Will not return none, will not return anything, just function will return. And see, this is the DFS function.
So could you just define this DFS function which you're telling that? Could you define DFS? You're telling DFS. I didn't get that point.
Spend some time. We'll get to it. Okay.
Got it.
Recursion
So
is a
you
little bit mind.
So for example, when you call this one, so first thing is DFS node. If not node, return. Again, result you want appending. Now DFS dot node dot left. Again, it calls this function. and
Yes.
runs till its node is none. Till
Correct.
that time,
Function is
you're
calling
adding the result.
itself.
Oh, got it.
See,
Got it.
we will do.
Yeah.
We'll do one dry run on this. Okay. Let us see. So this is the function. Okay. And I'm putting one result here. And this is the function definition. And after the function definition, I will just call this function. This is the definition of the function. Then I will call this function. I will say DFS on root. Okay. And then I will return result. So this is the entire code, recursive code. This is the recursive approach. If you're not understanding this, don't worry. The recursion we will discuss as a separate subject. But try to understand once. See what will happen. We are calling this DFS on the root. So we'll start from here. Okay, what will happen when we call DFS on the root? We are having DFS on root. Keep this example in mind, okay? I'm doing one dry run, trying to show you one dry run. DFS on root. Okay, this DFS on root will do what? This function will be called. Node here is what? Root. This function will not, this line will not run. Result dot append node dot val यहाँ पे करना है, sorry. What this will do? I will have a result here. In the result, we will append 8. Guys, are you following? Then what will come here? This function has not returned anything till now. It will call DFS node dot left. So what we will call? We will call DFS on 5. Guys, are you following? Yes or no?
Yes.
Okay, it will call DFS on. See, keep in mind that this function has not returned yet. DFS root. Within the function, one more function call made, which is DFS on node 5. I'm writing 5 here, but it is node 5. Again, this function will come here. It will say if not node, this line will not run because node value is there. Result dot append node dot value. What is the node? 5. So we'll put 5 here. And this will call what? DFS on node dot left. Again. So node dot left is what? 13. See, this function has not returned. It is calling one more function, which is
DFS of 13.
13. This is what? This data structure is what? Very beautiful data structure. What is this?
Recursion is calling again and again.
This is not. It is calling, but how it is keeping track? Stack. This is called as the recursion stack. कंप्यूटर को याद रखना है कि लास्ट फंक्शन कौन सा कॉल हुआ था. सबसे पहले रूट कॉल हुआ था. वो रूट फंक्शन खत्म नहीं हुआ, 5 कॉल आ गया. 5 खत्म नहीं हुआ, 13 आ गया. ठीक है. Now we are in 13. So what we will do? We'll come here. If not node, this line will not run. Result dot append node dot value. 13 we will put here. Okay. This function will call what again? It will call node dot left. Node dot left is none. It will call DFS on null. DFS on null जब call होगा, will come here and this function will return because node has become null now.
Then it will exit.
Huh? So this
DFS
function
of null is null only, right? Yeah.
null. So this function has exited now. This function has given the return. Okay. So where have we come? We have come to DFS of 13. We were doing DFS of 13. Okay. So we will go and now call DFS on node dot right. Guys, are you following or confused? This function DFS on 13, we were executing DFS on 13. We executed this line and then we executed this line, which was null. This line has completed now. Now we are coming to this line. So this line is what? Node dot write. Okay. So which is 7, DFS of 7. Okay. So if we come to DFS of 7, again, not node, this line will not run. Result of append, result dot append, node dot value will append 7 here. Okay. And then we will call node dot left. So 7 dot left is what? Null. Okay. So that will not run and it will return us. It will go left and right, both will happen. Both will be null. So it will return. Okay. So DFS 13 has now completed. This function has given as a result. And now we have done 7 also. So this DFS 5 also is done now. So where have we come back? We have come to DFS root. So we were running DFS root. We ran this line and we ran this line. And in this line only we were stuck. Now we have opportunity to come to the last line. Node dot write. So 8 ka jo write hai, that we will go there. So what will come here? We will have DFS of 20. We'll call DFS of 20. Again, we'll come and call DFS of 20. This line will not work. Append dot value, node dot value, 20 we will put here. Are we going correct? 8, 5, 13, 7, 20, 8, 5, 13, 7, 20. Okay. 20 we will append and then we will do DFS node dot left, which will be node DFS of 15. So we will call DFS of 15. Okay. DS of 15 will be called. DS of 15, DS of 15, this line will not work. This line will not run. Result dot append node dot val. So we will append 15 here. And then we will do DFS of node dot left. This will give me none. This will give me none. So DS of 15 is complete. Then we will go to DFS of 20, which was running before that. उसमें नोड डॉट लेफ्ट हमने कर लिया, नोड डॉट राइट अगर जाएंगे तो नल है, तो ये भी नन रिटर्न कर देगा, तो ये फंक्शन रन हो गया. Okay, and now if you see our entire stack is empty because root में 5 and 20 both are now executed. So this is also completed. So computer now has completed the running of DFS root, ये वाला function, and we have gotten our result. So this is only recursive approach, where one function DFS is calling itself and there is a base case. So when we are writing recursion, always keep in mind that we need to find a base case. I will formalize this a little bit more. Today, my topic of discussion is not recursion, but I just wanted to give you a glimpse of it. How many of you understood what recursion is? मजा आ गया. देखो कितना अच्छा एप्लीकेशन है स्टैक का. This is the application of stack. So when we were learning about stack, you guys were asking me where it will be used. So stack is very much used in the recursion call stack by operating systems to keep track of your function calls. टाइलर डर्डन लेफ्ट, पता नहीं ट्रॉमेटाइज हो गया टाइलर. क्या हो गया, नया पेज क्यों नहीं बन रहा? Okay, let us do one example. I will not do today. Okay, you guys do it. Come here and you do pre-order traversal. Okay, so you see here you have a question called 144 binary tree pre-order traversal. Okay, so you see read the question. Given the root of a binary tree, Given the root of a binary tree, return the pre-order traversal of its nodes values. Whatever we have discussed till now, same only.
But in the
And
question, they haven't told that is it a recursive or iterative. You can do anything.
sorry?
So we can implement this in two ways, right? Recursive.
Yeah.
and-
What you are using to implement, that is up to you. What code you are writing.
Okay. There's no constraint which we.
No. There is no constraint. Okay, given the root of a binary tree, return the pre-order traversal of its nodes value. So see how node is given to you. It is 1, null, 2, and 3. Okay, so this way of writing is like, this is basically saying 1, there is nothing, and there is 2 and 3. Is it like this? Yes, correct. This is 1, 2, and 3. So what is the pre-order traversal of this? Pre-order means what? Root, left, and
Root, left, and right. Yeah. 1, 2, 3.
so root is what? 1, left there is nothing, right there is 2. Okay, then left there is 3. So this is the pre-order traversal. So you can write the code that I have given. See, इसका क्या होगा? खुद से लिखते हैं इसका. Pre-order traversal क्या होगा? Root 1,
1, 2,
1, 2,
4,
4, 5,
5, 6,
6,
7,
7, then
3, 3,
3, 8,
8, 9.
9, 1, 2, 4, 5, 6, 7, 3, 8, 9. 1, 2, 4, 5, 6, 7, 3, 8, 9. ठीक है ना? We have done it correctly. Can you guys write the code for this today? I've already given you the code. My system is stuck. Can you guys write this for tomorrow assignment?
Yeah, we can give it a try.
Okay, just try it out, write both approaches, try to run it. Okay, and then tomorrow we will do other traversals, and then we'll also discuss level order traversal. Once we have done that, then we will dedicate some problems. At least we will do 5 to 6 problems in class and 5 to 6 problems in our live sessions. And then we will move to graphs. Okay, then we will discuss binary search trees. Okay, we'll target at least 10 to 12 questions at least in class, and 10 questions at least I will try to upload on my channel so that you have at least 20 questions. Imtiaz is saying please share the lead code URL for this assignment. There is a Google sheet, Imtiaz bhai. उसमें सारा questions का list है. You can see this list. Okay, so I will just mark the questions. Graphs, please कहाँ है? Please need
Anyone can share in WhatsApp group.
It's all shared already. You will be able to
Actually,
find.
I'm not able to see the history one, so I added in group.
I'll put.
Yeah.
Can you put this Excel in the recording lecture session?
मैं डाल दूंगा, बोल दूंगा किसी को डालने के लिए. यहाँ पे ये चेंज कैसे हो गया? Okay. Where is trees pre-order traversal? This one. Try to solve. We'll do this question. What was the question number? Question number 144.
ये जो आप YouTube में जो प्रैक्टिस करते हो इसमें भी नहीं अपडेट कर सकते हो क्या ये यूरोन में?
अरे उसको डाउनलोड करके अपलोड करना पड़ेगा, तो चैनल पे देख लो ना यार. उसको मुझे डाउनलोड करके किसी को ड्राइव पे फिर अपलोड करके फिर किसी को देना पड़ेगा. तो by the way, guys, class is over, so anyone has doubt you can stay back, otherwise we'll continue tomorrow. इसमें trees वाला section I don't know.
Ram,
it's not
is it
clear.
possible to share directly? Because we have a share link. Just share with me so that I can
Share
catch
what?
it. This sheet itself, Google sheet.
Yeah, I'll put it in the chat.
Yeah.
Take this.
Thank
Okay.
you. Sorry, this is the first time what I'm
No
attending here.
problem, no problem, no problem,
And
no
I'm
problem.
going through this.
It's created for, I've made this only for you guys, so it's for your use. इसमें नहीं है question, मैं डाल दूंगा. I'll put it. For now, I'm just putting one question here. 144. See, there is one more collab document. Here we have all the questions along with the solution. This is like for reference. You can keep this also. अच्छा मैं डाल दूंगा इसमें, अभी रहने दो, बाद में. Okay, guys, class is over for today. Anyone has any questions or doubts, you can stay. Otherwise, I'll end the session.
Yes, Ram, I have one thing.
बोलिए.
But I want to go with last because I want to give someone to be close here. Lalit,
No,
Ganesh.
tell, no problem.
Okay. So, Ram, this is the first session which I attended. Okay. 2 days ago, just I take the subscription. Okay. One of my friend is suggested to go through this and go with the Gen AI concepts. Okay. Hence, currently I'm working as a TPM. Okay. So I'm very good at the areas where the technical things. I'm working with the GCP cloud majorly. Okay. So now I'm pretty much interested to go with this Gen AI concepts where it's go and create a pilots things and these things. So these are my major goal will be to capture the high level. Like as you mentioned, that's the one thing you mentioned, right? So the if you go and learn something as a linear way, go to the leaf node to top. Okay, it's going to the depth. Okay, so I'm going to the level wise. I'm planning to take with the level wise to go to the capture and everything for these areas. So I need your assistance as well as really you will be proud once I get done. Definitely.
Yes. So that is correct strategy for you because you are experienced person. So I think you will be targeting some manager type of roles. Okay.
Yeah, currently
not
I'm
IC
pursuing.
roles.
Yeah, currently I'm pursuing as a TPM. Okay. But nature of the role previously it's not technical more. Nowadays it's very technical because more of the agentic AI will come. Gen AI integration, some migration parts of the data to writing Vertex AI to giving some kind of chatbots to the clients, everything. This entire thing will be involved here. Now, at least I should aware what all the technical terms, how it works, the conceptual. Even though I don't want to go with the hands-on to making these things because team will be sitting there, but at least I should know
familiarity
to
with
become
everything.
an umbrella for them.
Correct.
That's how I'm thinking. That is the only one reason to be here. I am right now.
That is the correct strategy for you.
Yeah, started with Python. So anyhow, I'm good with Python, but still I want to be refreshed more and more because last 3 years I don't have any hands-on.
Do a lot of practice on Python. Become a good. I will suggest no matter what you're doing. If you learn programming, it's only going to benefit you.
Sure.
So become good at programming and get a very good high-level understanding of generative AI.
Okay.
Like how not how LLMs work and the maths behind that and how does transformer works, fine tuning, not all of that, but how generative AI and agentic workflows, they are impacting business problems.
Yes, sure.
Right. You don't have to build those agentic systems because that is where the developers or the engineering team is going to work.
Yes, right.
But you are kind of the link between engineering and the product or the business.
Right.
So even when we are working, we work with AI strategists, we work with product managers. So their job is to understand the business and have a high level understanding of engineering so that they can bring that together,
Okay.
and they frame the roadmap, or they create like a product requirement documents, and then the engineering team works on that scope. So if you understand the business and if you understand how generative AI can solve those problems and you are able to create the strategy, so that might be the best pivot for you at this given point of time.
Yes, Ram, that's what also I'm thinking. So,
Yeah.
so now another suggestion, what I'm expecting from you as a tutor, right? Assume that the Euron is really good platform, which has been achieved here. I will be rich here. But what kind of courses so that I can help very quickly to me and get the right target?
Again, learn good basics of Python.
Okay.
Step 1. Step 2, familiarize yourself with the popular libraries that people are using today, like frameworks like LangChain, or even no-code agentic workflows. There are a lot of no-code agentic workflows coming into picture. How agents are created, what are MCP servers, right? How they are deployed, what are the common problems that are that people face when they take when they move from deploying a MVP or deploying a demo to an actual production system. What are the possible common problems that people face, right? What impact it has on the business problem? What kind of problems can be solved? What kind of problems are commonly being solved by other people who are in the industry? If you're working in a particular sector, other companies in the sector are using the generative AI for what use cases? Are they using in customer service? Are they using for automations? Are they using for um, creating some kind of chatbots? For what they are using? So this kind of knowledge, like a high level business knowledge around generative AI, you should have. And in terms of your own coding or a roadmap which you're asking, learn Python, learn creating basic agentic workflows, both code and no code, and how common problems can be solved using them, and more importantly, what are the common challenges, right? Where you might guide somebody that, okay, we are doing this and we are using this approach, but using this approach might come with so and so problems. How do we navigate that, right? So your domain knowledge should come alongside. Don't start from scratch. That is the advice that I give to anyone who's experienced, that don't dump everything you have done till now and start afresh. Don't do that. Use AI and generative AI knowledge to improve what you're already doing. You're already working in a sector, you're doing TPM work, whatever you're doing. Use your knowledge, apply that to what you're doing currently. That way, I mean, it makes sense.
Yeah, sure, Ram, definitely. I'll follow the instructions. Just to catch up, whatever till now has been completed, because I'm too late in this game right now, right? So whatever done so far now, so that Excel, maybe I think it's a completely breakdown. I can going through that, so that we have to be follow that, right?
So we have done basics of Python.
Okay.
So you can watch the recordings.
Okay.
Basics of Python. And then we started with data structure. So in data structures, we have done 4 data structures. So we do 2 classes, Saturday, Sunday. And then I do 2 live classes on my YouTube channel on weekdays, where we just do practice of whatever we have learned. It is like kind of an extra this thing. So, and all the questions, recordings, everything is available. So if you're not very good with Python, first I will suggest do Python course. You can follow my lectures, or in Euron, you will find many other lectures also, whichever you feel comfortable, but do basics of Python up till oops.
Okay.
Do up till oops. That is mandatory for everyone. After that, if you want to become a data scientist, you go to data science libraries. If you want to come to generative AI application building, you do that. If you want to become backend engineer, there is a different path. So once you have learned till oops, there are different learning paths for Python. So depending on your interest, you can take one of those paths.
Yeah.
Okay, so for you, it will be taking a generative AI course, which
Actually,
might be there, I think.
Today I was with there for that to get that online, which is something is taken from, I don't know his name actually. One of the live courses has been going. Today, due to unavailability, it's cancelled. Sudhanshu Kumar.
So you can take his
due
course.
to his unavailability, so today live class is being cancelled. So that's the reason. So anyhow, I want to be backup for Python also, PSO things also. So I asked the team to be joining here. So just I joined here. Just I went to the DSA, whatever you covered so far. Now it's really good. I'm very impressed, and the way you are teaching, it's like spoon feeding. If no anyone can understand, if I understood correctly, even though my kid is studying on 9th, maybe if I ask, I'm really interested to ask her to be join this class.
It's a good thing. DSA,
Yeah.
It's not just for mostly for job interviews, but in generally like gives you a lot of confidence if you understand it. So
Exactly.
it's good, and it doesn't take much time.
Yeah.
2-3
It's a
months.
boost up for our whatever programming we have.
Yeah.
It's kind of a boost up it will
Yeah.
give to us to make little really high. Yeah. Thank you, Ram. Thanks a lot once again.
Thank you.
Okay.
Thank you.
So definitely I'll join the class tomorrow also.
Yeah,
So let me go through this. In meanwhile, I want to get some time to go through these things, whatever you covered till now. So
Yeah.
I'll come up with you. If you
Sure.
have anything, definitely I'll reach out to you.
Yeah.
Yeah. Thanks a lot. Thanks, Ram. I'm dropping off if you want
Yeah.
anything.
Ram, before you wind up, I just wanted help from you. So I was working on the GenAI. I having a lot of dependency issues on most of the projects.
What is issue?
Dependency issues on most of the projects. So I wanted to know some good channel where I can get support on this. Some backend support for dependency issues.
Like dependency issues, like
A lot of it's asking for a lot of library issues. I mean. Because what is taught and it doesn't work in my laptop. So of course I do some search on Stack and all, but is there any good channel where I can get some issues where I can resolve most issues on GenAI?
No, those you are getting some errors. So channels, you will get tutorials on how to use something. But if you're working on a library and you're not having, you have not installed that library properly, or there is some version conflict, all those things.
It happens like it's not connecting, it's not getting a right link and all things like that. Then I have to give Python as /m, and what is taught and what I'm doing is different. And I mean, of course, I do my own research through Google and all. So some tough
Depends
cases I'm getting
exactly.
stuck. I can take a simple case of chatbot. Medical chatbot was done in my class, and it runs the class. But when I do in my system, it doesn't work. It's the same code. So what I
You must
find
be
is
doing some fundamental thing might be wrong where you are not importing properly or something. You create your environment, like Kumar is saying in the chat. You have to create a different environment, and then first you create your requirements.file, that what are the requirements that you have.
Yeah, I
And
mean,
then install.
I know that these are the basic things. Even after doing that, I'm getting some dependency issues, and somewhere I'm getting stuck. I mean,
Yeah,
we are
so-
having problems like pydantic issues and all, where data has to be
You
generated in the right
you are
manner.
talking about that GenAI classes, the
Yeah.
example.
The medical chat,
So
the medical
you
chat, the
can ask
first.
in the group itself. So many guys
you
they
see,
are little done,
you
so they
ask in
can help.
the so see what you are having is a very specific niche problem to you.
Yeah.
Okay, you will not find any such.
And the thing is, Ram, that because the way it was taught in a mode, in a right channel, and it's been followed. When I follow that, I'm still getting some issues. Maybe
that's part of learning.
So So I did that, but I'm getting stuck in a first
Take
project
that
itself.
screenshot, or you take that error message. Whichever group you are a part of, you paste there, because other people also might be doing the same thing.
I did that. Then I think I got a reply that you have some dependency issues, and also I was like wondering what is this? I mean, because it is my first project, and even there is the first project, medical chat was the first project, and it didn't run in my laptop. It ran for some people. Of course, there are a lot of people, not a lot, few of them for whom that project is not. I mean,
It's
though
a
they have
common
understood.
these are common issues that you will face when you're running. So the what would be happening is the environment that you have created, you may not have installed the proper libraries, or the name of the files that you must have given might be conflicting with the inbuilt library. Sometimes that also happens. Like you're working on
Yeah.
LangChain and you're given the file name as LangChain.
No, no,
You're
not to
trying
that kind of
encode
error.
that. Something
No,
like
no,
that
no.
must be happening.
Not to that kind of error. I mean, that is understood, but some basic, it's not catching my environment. When I gave Python underscore m and gave the environment library, it caught up there. But after that, again, it's getting stuck with some issues internally.
You can discuss with me tomorrow, or better will be that whatever course you're doing, in that course, there will be some doubt support, right?
Yeah, I did that. I put a post. The reply was they said dependency issue. So I thought they
Follow up there, and instead of doing that, do like a live this thing where you can share your screen. It will be a very small thing. It might be a little irritating for you, but
I mean, it's irritating that we are all gone some 6 steps projects ahead, and I'm still struggling with the
it will
first
be a
part.
very small thing that you might be overlooking. It will get solved within few minutes. But someone has to point out that exactly this is the mistake you're making. So catch hold of someone in that course, okay, do a screen share and walk them through. They will point out that, okay, this is the wrong command or this is the wrong environment or something like that. And it will get sorted out. Like it will be a very small issue. Dependency issues are not, it will solve very immediately, or some wrong version of something you might have installed.
Yeah.
So
Fine.
reach out to someone on the doubt support or catch hold of someone in the course who has run it and sit on a one-on-one, do a video call, screen share, and you'll be able to figure that out.
I only reason asking if there's some good channel where I can get support on this, like things
Channel
related
you
to
mean on Euron?
Yeah, no, not on Euron, on GenAI generally.
Not sure. Like dependency issues separately, I don't know. You will find people who will teach you, but I don't know. Better will be to catch hold your classmates, batchmates.
Yeah, I got to do that. I mean, the response is not very positive, but just thought I would
follow up.
Okay.
You will have some support there, or you can use ChatGPT. In fact, there also you can get some support.
Fine.
All right, guys. I'll see you tomorrow. Bye bye.